What else? Can't seem to find where I went wrong.
So deep. can find out what I already know.
are no islands in space.
And in fact is in the works.
Where the life situation of blood is bleeding, and you can't be alone for too long. You are weeping, and you hear her name in every song. You know you need her. Try to tell yourself you don't even care. You go out, but you're not really there. And there's nothing you can really do. It's a bitch when you got the blues. With joking and you're drinking with your friends, but you're hoping and you're thinking how things could be. And you know that you are raped inside. You feel like screaming. I miss you so. Got a hole in my heart to my soul. Why I have to pay these dues? It's a bitch when you got the blues. Still so much I had to learn about you, baby. And without you, my world don't turn. I'm going crazy. Oh, baby, I miss you so. Got a hole in my heart through my soul. And there's nothing I can really do. It's a bitch when you got the blues. Yeah, it's a bitch when you got the blues.
With it, because I want to know about some stars now. Let's check it out. It's been a while. I feel good. I'm tingly all over.
Not known.
Because I won.
An alternative electric sun model was proposed in 1979 by the engineer Ralph Jurgens. It explains simply the critical longevity of all electrical lights. It is plugged in.
I'll come and say hi in a minute.
Galactic circuit, and galactic circuits are the basis of plasma cosmology, which is ignored by astrophysics, but was developed by experimental plasma scientists and engineers in the 20th century. I would say plasma physics is next-gen physics, quite unlike mathematical Big Bang cosmology. Plasma cosmology is simply explanative and has proven to be predictive. Only in the last few years have the circumstances arisen to enable the more recent electric sun model to be tested, called the Sapphire Project. Cutting-edge engineering from Dwarfs International Incorporated was contracted by the International Science Foundation to experimentally test the electric sun model. Dwarfs International Incorporated is an independent body which has no affiliation. Recently, the Sapphire team shared an extraordinary update on their results to date, and I don't know if you saw the video, but it is extraordinary. In part one of his two-part presentation, our chief science advisor, physicist Walt Thornhill, discussed the Sapphire experiment, its results, and its promise for the future. And must be part two already? It is short. In part one of this presentation, physicist Walt Thornhill began his analysis of the recent remarkable update by the team behind the groundbreaking scientific experiment, the Sapphire Project. For the first time, an independent experiment has been conducted to audit the electric sun model, first proposed by engineer Ralph Jurgens in the 1970s. Sapphire's principal scientist and chief engineer Montgomery Childs recently said of Sapphire's results, "In all our experiments and discoveries, we have found no disparities with the electric sun model. We believe the Sapphire experiment validates and supports the electric sun model." Childs is president and founder of the engineering firm Dwarfs International Incorporated, which was contacted by the International Science Foundation to experimentally test the electric sun model. So coming into it, Montgomery Childs was a neutral third party, which is what science is all about. Explore all the avenues. As noted previously, Dwarfs International Incorporated is an independent body which has no affiliations with the Thunderbolts project. And that is check and mate. But good luck trying to get mainstream to even pretend, because they're just too busy being obtuse. 2 + 2 is 7. NASA's dim view of stars. The Cone Nebula shows a star at the top of a conical-shaped dusty plasma festooned with lights. The image strikes an instinctive chord. The mythical celestial world mountain, around which the stars revolve. That was the one that I thought had Lucy on the top of it. Maybe she left. The cosmic Christmas tree with
I think
lights,
it looks more like a
fireworks
woman with really
displays
long
against a night
black
sky.
hair.
Why? Because it reflects back to us
It's in a
our own
ponytail,
prehistory,
kinda.
when a strange drama was taking place in the sky. The Earth was enveloped in a towering polar auroral plasma, flashing with light and with bright celestial bodies at its distant focus. How do we know? Prehistoric mankind around the globe chiseled representations of what they saw into solid rock. The effort required was prodigious, the motivation extraordinary. Modern astronomy seems unable to address the issue, offering instead a comfortable myth of cosmic stability. 20th century technologies have enabled astronomers to see the stars and planets ever more clearly, but their predictions are clouded by centuries-old beliefs about celestial harmony, that the heat of the light of stars is due to some kind of internal fire. That we understand gravity sufficiently to declare that it obeys a universal law and alone governs cosmic evolution. These perceptions have become dogma, and dogma hinders progress. So it is not surprising that a growing number of critics see gravitational cosmology of the Big Bang as sterile and irrelevant to any real understanding of our place in history in the universe. The fact that it has nothing to say about life itself, the deepest mystery of the universe, is just one of countless signs that the present field of view is too limited. For the moment, I want to feature two reports in December 2014, I believe. Let me see, make sure. 2008. For the moment, I want to feature two reports in December that show astronomers do not understand stars. The view of stars as skies, as fires in the sky, was understandable when chemical fires were the only source of light that we knew, and the only question we asked of stars was, how do they shine? But that view failed. Then we realized that the stars had to burn steadily for eons. The discovery of nuclear energy offered an answer to this new question without having to reevaluate the accumulation of other assumptions about stars. In other words, it was the lazy way. The thermonuclear assumption was never proved, and observations that contradicted it were never crucial enough to compel astronomers to doubt it. It came full circle and led to a futile, decades-long effort to mimic the conjectured process to provide power on the Earth. All the while, a clue to a better answer stared the experimenters and theoreticians in the face. They were using electricity to trigger thermonuclear reactions. Maybe the sun was doing that too. Now, I just heard Eric Dollard say that an H-bomb, it shorts out the Earth's electrostatic field. So, yes, nuclear weapons are electric. Radiation comes from electricity. We use electricity as a convenient means of lighting and heating. It doesn't require the power to be generated on site. We've discovered, that thin transmission lines can carry great amounts of power over long distances, from generator to light bulb. Nature is parsimonious in achieving its ends. After I tell you this, you might never look at an X-ray machine the same again. The heart of an X-ray machine is an electrode pair, a cathode and an anode that sits inside a glass vacuum. That's right, X-ray machines are electrical. They make X-rays using electricity, and even in the micro world, planets work the same way. Why wouldn't stars get power from natural transmission lines? The satisfying answer is that they do. Radio astronomers can trace the telltale magnetic fields in deep space that they have. The magnetic fields mark filamentary cosmic transmission lines, carrying electrical power between galaxies and stars. NASA's dim view of stars. The latest report from NASA is a fitting end to the year of the electric universe. It demonstrates that the electric model of stars envisioned the latest observations, while NASA researchers again mask their assumptions by stating them as facts. Ironically, the report refers to some stars as low-energy fluorescent light bulbs. As usual, all the science reporting agencies repeat NASA's words without critical comment. Mainstream media rarely do investigate science journalism. As usual, all science reporting agencies repeat NASA's words without.
You mask your assumptions by stating them as facts. You know anybody like that? I sure do.
Critical comment. No doubt. Just parrots. Astronomers find the two dimmest stellar bulbs. Yeah, they don't mind calling them bulbs. Well, that's just admitting that the universe is electric. It's a tie. The new record holder for dimmest star-like object in the universe goes to twin failed stars, or brown dwarfs, each of which shines feebly with only 1/1,000,000th the light of our sun. But if you had a little planet right next to it, that would be all it would need inside its plasma sheath. Comet, as we shall see, the notion of twin failed stars is a theoretical assumption and not a fact. Every single thing Standard Model does is a theoretical assumption. In the electric universe, there is no such thing as a failed star. They have no thermonuclear engine to fail. All bodies in the galaxy receive external electrical energy from the galactic circuit. Radio astronomers, for the most part unwittingly, trace the circuit by mapping the magnetic fields of galaxies and stars. These fields are generated by the electric current flowing in the circuit. The circuits are unrecognized due to the mistaken conviction that the magnetic fields can be frozen into plasma. It can't even be frozen into rock. It weakens. The father of plasma physics, Hans Elfing, appealed against this mistaken notion in his Nobel Prize acceptance speech in 1970. But to give up this false belief would require discarding decades of theoretical work, reputations, and Nobel Prizes built upon it. The report continues. Previously, astronomers thought the pair of dim bulbs was just one typical faint brown dwarf with no record-smashing titles. But when NASA's Spitzer Space Telescope observed the brown dwarf with its heat-seeking infrared vision, it was able to accurately measure the object's extreme faintness and low temperature for the first time. What's more, Spitzer data revealed the brown dwarf is, in fact, twins. Both of these objects are the first to break the barrier of 1/1,000,000th the total light emitted power of the sun, said Adam Bergasser of the Massachusetts Institute of Technology, Cambridge. Bergasser is a lead author of a new paper about the discovery appearing in the Astrophysical Journal Letters. Brown dwarfs are misfits of the cosmos. They are compact balls of gas floating freely in space. But they are too cool and lightweight to be stars, and too warm and massive to be planets. The name brown dwarf comes from the fact that these small star-like bodies change color over time as they cool, and thus have no definitive color. In reality, most brown dwarfs would appear reddish. Not much of a difference between red and brown, if they could be seen with the naked eye. Their feeble light output also means they are hard to find. The first brown dwarf wasn't discovered until 1995, while hundreds are known today. Astronomers say many more in space still waiting to be discovered. Comment: all stars are in an electrical phenomenon. There are no misfits in an electric universe. All of the assumptions being heaped upon the meager photos received from deep space merely serve as usual to force fit the data to the standard model of stars. The very name, brown dwarf, assumes that these stars are compact balls of gas floating freely in space. In stark comparison, the electric model describes them as huge, because the light from a star is a plasma discharge phenomenon with only a loose relationship to the physical size of the star and a strong dependence on the electrical environment. Brown dwarfs do not simply cool down over time and wink out. They are externally powered electric lights. In December 1999, Wall wrote, "The apparent size and color of an electric star is an electrical phenomenon. If Jupiter's magnetosphere were lit up, it would appear the size of the full moon. The light of a red star is due to the distended anode glow of an electrically low-stressed star. Red giants are a more visible and scaled-up example of what an L-type brown dwarf star might look like close up." The report continues. Astronomers recently used Spitzer's ultra-sensitive infrared vision, which they shut Spitzer down, by the way, with no real explanation, to learn more about the object, which was still thought to be a solo brown dwarf. These data revealed a warm atmospheric temperature of 565 to 635 Kelvin, 560 to 680 degrees
They don't like to share.
Fahrenheit. While this is hundreds of degrees hotter than Jupiter, it's still downright cold as far as stars go. In fact, it is one of the coldest star-like bodies measured so far. To calculate the object's brightness, the researchers had to first determine its distance from Earth. After 3 years of precise measurements with the Anglo-Australian Observatory in Australia, they concluded that the star is the 5th closest known brown dwarf to us, 17 light-years toward the constellation Antilla. This distance, together with Spitzer's measurements, told the astronomers that the object was both cool and extremely dim. But something was puzzling. The brightness of the object was twice what would be expected for a brown dwarf with its particular temperature. The solution? The object must have twice the surface area. In other words, it's twins, with each body sharing only half as bright, and each with a mass of 30 to 40 times that of Jupiter. Both bodies are 1 million times fainter than the Sun in total light, and at least 1 billion times fainter in visible light alone. These brown dwarfs are the lowest power stellar light bulbs in the sky that we know of, said Bergasser. And like low-energy fluorescent light bulbs, they emit most of their light in a narrow range of wavelengths. In this case, in the infrared. Comment. Bergasser's description of brown dwarfs as low-energy fluorescent light bulbs is the closest he comes to the truth. Like fluorescent lights, brown dwarfs require electricity. And the solution to the problem is simple. A single red dwarf with an extended red anode glow can provide the extra brightness without postulating an unlikely twin. The report continues. According to the authors, there are even dimmer brown dwarfs scattered throughout the universe, most too faint to see with current sky surveys. NASA's upcoming video field infrared survey Explorer mission will scan the entire sky at infrared wavelengths and is expected to uncover hundreds of these inconspicuous characters. The holy grail in the study of brown dwarfs is to find out how low can you go in terms of temperature, mass, and brightness, said Davy Kirkpatrick, the co-author of the paper at NASA's Infrared Processing and Analysis Center in California, Institute of Technology, Pasadena. This will tell us more about how brown dwarfs form and evolve. Comment. In an electric universe, stars do not evolve. The notion of stellar evolution and the age of stars is an invention of the standard thermonuclear model of stars. And for so long as scientists cling to an unworkable theory of stellar formation by gravitational accretion, new findings will serve only to add to the confusion. 2 + 2 = 7. I predict that further discoveries by the Wide Field Infrared Survey Explorer in this category will require the same ad hoc assumption that the radiant surface area based on standard theory must be accomplished by multiple star systems. The odds against finding so many multiple systems will become astronomical. Success for the electrical model of white dwarf stars. Yeah, this is the same thing I'm talking about on Solaria. The main sequence is the backbone of the observations, but there are sharp discontinuities between the main sequence and giant stars and white dwarfs. In the standard thermonuclear model of stars, the explanations for these discontinuities are beset by many observational discrepancies and ad hoc patches. In the electric star model, such discontinuities are a natural feature of a plasma discharge. Main sequence stars operate like arc lights in a cinema projector. The plasma discharge at their photospheres is in arc mode. The main sequence is a direct result of increasing the current density at the surface of the star. The red supergiant Betelgeuse is dimming. Will the bright star Betelgeuse finally explode? A look at the dimming red giant in Orion's shoulder. It can't hurt to look up at the night sky, just in case. Well, one of the brightest stars in the sky has been dimming. But while it might be signaling that it's ready to explode, it's probably just fading because of strange stellar physics. Betelgeuse, a reddish star that's one of the brightest in the night sky, has been noticeably fainting or getting dimmer. The approximately 8.5 million year old star, which is part of the Orion constellation, has been one of the most recognizable stars in the sky because of its brightness and coloration. But this recent dramatic fading has prompted scientists to suggest that the star might be entering a pre-supernova phase.
What about if stars
dimming
get
before it
pregnant? They get real
collapses and
big like
dies
people do.
in fiery supernova explosion. If the star does become a supernova,
I know, it
Betelgeuse,
sounds silly, right?
you know, some people say Betelgeuse, I guess
think
it's just
that they
a
give birth to each
tomato
other.
thing, would likely be as bright as, or even brighter than the moon for weeks. At 642.5 light years from Earth, it would be the closest supernova observed and recorded by humans, closer than the Crab Nebula, which is 6,523 light years from Earth, and is the result of a supernova reported to have taken place in AD 1054. This also means that if we see Betelgeuse explode tonight, the supernova really took place over 600 years ago. We're only seeing it now. It's a nice picture. Will Betelgeuse or Betelgeuse explode? The brightest stars in the sky. It'd be brilliant. The star would be so bright that it would make it difficult to see other stars near it. Edward Ginnon, a professor of astronomy and astrophysics at Villanova University, who reported the dimming in an astronomer's telegram, told space.com, it would be the brightest supernova ever observed in our galaxy. But will we really see Betelgeuse explode? A massive dimming star. It's not surprising that the extremely massive star, which is likely about 20 times the mass of the Sun, has been dimming, because it's a variable star, meaning its brightness naturally shifts, something that scientists have observed for decades. The star has been classified a red supergiant star because of its size. However, with this recent dimming, the star's brightness kept going down beyond the limits that we scientists ever saw. It went outside of its usual parameter or comfort zone, Ginnon said. It's dimming a lot more than we've seen. Serafina Nance, an astronomy graduate student who studies Betelgeuse and stellar explosions at the UC Berkeley, told space.com, but does that dimming foretell an explosion? We know massive stars like Betelgeuse will explode as a supernova. The question is, when? There really haven't been close observations of them, supernovae, before they go off, Ginnon said. He explained that while some think that there wouldn't be any major changes in the star until just hours before it blows up, others think that it would start to dim about a year before exploding. There's no true consensus. While it's possible that the star could explode any time between now and 100,000 years from now, this dimming might not actually be a sign that it's about to blow. Both Nance and Ginnon said, that's a really nice picture. Shows you how much bigger it is than the Sun. Holy smokes, it's a monster. It almost looks like it's exploded now. If it looks like that. Oh, artist visualization shows Betelgeuse and as it is revealed by new observation techniques with ESO's Very Large Telescope. Well, then show the images with the telescope. A false alarm? While he acknowledges that it could explode soon and this dimming could be a sign that the explosion may happen relatively soon, I believe it is going to blow up now, Ginnon said. Oh, I believe it isn't going to blow up now, Ginnon said. I hope it does, but my bet is that it's not going to. It's going to come back up, get brighter again. Nance admits we could absolutely be wrong. She said, referring to her theory, that the dimming is not a sign that the star is about to explode. That said, I do think that this is more indicative of really interesting physics that's going on with the star rather than an imminent explosion. If it does explode and we're wrong, awesome. I would love to be wrong. I would love to see that, Nance said. While it would be pretty amazing to witness the ultra-bright transformation of such an enormous and close star into supernova, Gannon said it seems more likely that this dimming does not indicate a pre-supernova phase and can be explained in another way. Food for thought. What if the sun is connected to Betelgeuse and it gets its electrons from it? What would it do? Something to think about. According to Nance, they wouldn't want it to blow up then, would they? According to Nance, no one is exactly sure why this stellar fainting is happening. It could be caused by instabilities within Betelgeuse. She explained that different parts of stars can have different densities, and this density instability can cause energy to rise and fall within a star, moving energy from its inside to its outside. This, in turn, can cause changes in brightness, cause the star to get bigger and to contract, and much more. Nance added that this extreme dip in brightness could also be attributed to magnetic activity in the star. We know magnetic has to be electric, but it is difficult to model that activity through simulations, so they do not yet know if that is the definite factor. She even added that it's possible that matter ejected from the star is creating a sort of dust fog that's currently obscuring and dimming the star. The likely lack of nearby explosion might make this star seem less
St.
interesting.
Pauli girl, I'm in the
But
Great
Nance
Hall.
thinks just the opposite.
Somebody.
I think that this is really interesting to watch and really interesting from a physics perspective of trying to better understand how massive stars experience periods of variability, she said. You should still look up. Now, while both Nance and Gannon think that it's most likely that Betelgeuse is just displaying a dimmer appearance because of some interesting stellar physics, they also agree that an explosion in our lifetime is still possible. It's worth it to look up and look for the dimming star in the night sky. While I don't think it's going to explode anytime soon, Nance said, I'll keep my eye on it just in case. We don't know what's going to happen. Wow. There are absolutely limits to our models, she said. I'm going to look up at the night sky and check that it's still there every time I go outside, even if it is in a pre-explosion phase. It's exciting to watch the star now as it dims. It's kind of neat to see astrophysics or astronomy and stellar evolution in action, Gannon said. These changes are usually so slow that you can't observe them. Meet Alma. Amazing photos from the giant radio telescope. And that was from space.com. Thank you, space.com. And had some comments. I'm not going to read them.
I like to labor the point.
Then above that you have the energy flow, and of course it's normal to expect that incoming electrical energy will excite the plasma out here first, and then as it gets into the more dense atmosphere it will exhibit discharge activity. Out here it's a coronal glow, in here it's normal electric arc phenomena. So the energy to heat the electric sun comes externally from the galaxy. The electric discharge becomes intense close to the sun, heating the thin atmosphere of the corona to millions of degrees, and the superheated corona is a familiar glow discharge phenomenon recognised by high voltage engineers. Now we come to the HR diagram. It's based on observations, it's not based on theory. It's a scatter plot, not an evolutionary plot, and the luminosity and colour of a star depends on its size and the current density at its radiating surface. Discontinuities exist. You've got white dwarfs over here, red giants here, and red and brown dwarfs, which are all discontinuous with the main sequence. These are all stars with bright photospheres, so they have that regulating mechanism. Of course, the astronomers got it back to front. If you do a mirror image, then you have a more understandable arrangement where the stars get brighter and bluer as you increase the current density, so that you get this straight line curve, which is exactly what you'd expect. Red stars have to expand. That's both red dwarfs and red giants. They're stars which are not collecting enough electricity to satisfy the discharge, so plasma adjusts. It's like a living thing almost. It adjusts to its environment. And so it expands the anode sheath to collect enough current. And some of those anode sheaths are monstrous. You know, Betelgeuse, if that star was in our solar system, its photosphere reaches out to the orbit of Jupiter. White dwarfs, on the other hand, may be normal-sized star, but they have no bright photosphere. Their upper atmosphere is in direct contact with the plasma of space. They have only a faint white corona. Imagine if the sun's photosphere turned off, you would see this white envelope, very faint, but very white, very high temperature in appearance. So stellar evolution is a fairy story. This is V838 Monocerotis. This erupting star transformed itself over a period of months from a small underluminous star, a little hotter than the Sun, to a highly luminous, cool supergiant star undergoing rapid and complex brightness changes. This was the quote of the article describing it. The transformation defies the conventional understanding of stellar life cycles. It's a very complex story. I've been through it, the theory of it. So here's a red giant. This is actually Betelgeuse. It's 500 times the size of the Sun, and it has a hot spot. You've got to ask yourself, what's a hot spot doing on a red giant star? What happens is as that envelope expands, the electric field grows stronger because it's trying to collect electrons from space. But on the other hand, positively charged particles, in other words, its stellar wind, are accelerated more strongly the other way. So you have this anomaly where these cool stars have the most powerful winds known. And if the stellar wind is being boiled off, so to speak, this doesn't make any sense at all. And Betelgeuse sports a hot spot, and I've suggested it may be above one of its poles because one of the Alphane circuits shows that one of the connections of the electric circuit is to the poles of the star. So we may be staring at one of the poles. Giants and dwarfs. The usual story is that stars consume their fuel and change to giants or dwarfs. The story is complex, unverifiable, and regularly contradicted. This is another version of the HR diagram there. And astronomers are perpetually astonished by unexpected changes in stars. This is a white dwarf system. Sirius B is the white dwarf, and Sirius A, you'll see an optical light here. Sirius A is very bright in the sky, and Sirius B is almost invisible, and it's a faint white, so-called white dwarf. Now, if you look at it in X-rays, it's the reverse. Here's Sirius B, it's brighter than its optically bright partner Sirius A. This is what you'd expect, where the discharge reaches into the ionosphere directly of a star. The X-ray output is high, the visual light output is low. There's nothing special about that. It can be an ordinary star. It's just that its partner may have usurped most of the current. It's supposed to be a collapsed star at the end of its fuel. But how can an old and a young star be together? Because here you have an old and a young star, so to speak, under the conventional ideas, together. A white dwarf has no bright photosphere. Its white light and X-rays come from an intense corona. Here's the different star types, and I've shown how I think they would look. A red dwarf is actually quite large. In other words, it's like a red giant in miniature. A red dwarf was discovered, and the astronomers decided that it was putting out too much light for what they assumed was a dwarf star. So they said, it must be a pair of red dwarfs of exactly the same size and power output. I suggested, no, it's a single red dwarf. It's just much bigger than anyone ever expected. Main sequence star, it is covered with photospheric tufting, tufted anode and a controlled discharge. Blue giants are a large star under high electrical stress. Red giants are a normal star under low electrical stress, and it develops a bloated glowing plasma sheath. A white dwarf is a normal star in direct contact with space plasma and has low luminosity.
Puzzling. Betelgeuse is one of the 10 largest stars. If it accompanied the Sun's position, its outer
After it
envelope would
does
exceed
this essay,
Jupiter's
I'm going
mean
to come
orbital
out and
diameter.
stop it.
It is so diffuse, however, that the orbits of the inner planets might not be affected. Red giant stars like Betelgeuse are relatively cool, but extremely bright, so they are thought to be large. However, in the electric universe, since they possess coronae, red giants might be small inside their energetic atmospheres. Betelgeuse is only about 2900 Celsius, so it creates problems with the thermonuclear model of stars. Such a cool temperature should not harbor an extreme radiative output. Red giants are old as astronomers measure age, since the so-called main sequence theory states that stars go through a well-established evolution. That evolution is said to follow a path that depends on thermonuclear fusion.
girl,
Hydrogen
join me
gas
in
is
chat if
compressed
you're out
in the
there.
star's core until it
She probably
fuses
left,
into
huh?
heavier elements. Therefore, a
if
star's
anybody wants
mass
to get in,
and its
come
spectrum
on
are thought to
down.
indicate its age. Because these ratios of different elements is said to provide an idea of how long it took to convert its original substance into those other elements. Betelgeuse is notable for gigantic bubbles of hot gas that are in constant motion. Bubbles as large as the star itself, since it has been observed to eject massive amounts of stellar material, greater than 6 times its diameter. It has been proposed that Betelgeuse is undergoing violent vertical oscillations just beneath its surface. It is that energetic motion that is causing the hot gas to blast into space, just as bubbles in boiling water erupt with puffs of steam. Recently, the massive star is reported to be shrinking, or at least dimming, causing some confusion in astronomical circles. Since Betelgeuse is a variable star, that behavior is not unexpected. Sunspots are seen on its surface. However, there are only 2 of them occupying over 1/3 of its area. They are said to be the signature of heat transfer from the interior through matter convection. In other words, the star is acting like a pot of boiling water, a strictly mechanical phenomenon. The electric star theory provides another explanation, an explanation that relies on the electrical connection stars have with their galactic neighborhood and with the universe. Stars shine because electricity flows through each galaxy. As written many times, stars can be thought of as giant spheres of electricity. It is this simple hypothesis that best matches observational evidence. As mentioned above, red giant stars are relatively cool but extremely bright, so they are interpreted to be quite large. Dr. Donald Scott proposes that the giant characteristic is a result of a large corona and not because the stellar disk is oversized. Physicist and electric universe advocate Wal Thornhill also proposes an electrical model for Betelgeuse and red supergiant stars. In general, electric currents in space are primarily due to the flow of electrons through interstellar plasma, and not the movement of positive ions. This means that the stars are lacking in electrons. Because of a charge separation process, stars can be considered positive anodes in a galactic glow discharge. Therefore, red stars are those stars that cannot satisfy their hunger for electrons from the surrounding plasma. So the star expands the surface over area which it collects electrons by growing a large plasma sheath. That becomes the effective collecting area of the stellar anode in space. The growth process is self-limiting because as the sheath expands, its electric field will grow stronger. Electrons caught up in the field are accelerated to ever greater energies. Before long, they become energetic enough to excite neutral particles they chance to collide with, and the huge sheath takes on a uniform red glow. It becomes a red giant star. Betelgeuse is an electric star, and the bright regions are areas where electric currents are flowing with the greatest amperage. Stephen Smith. All right. Thank you, Stephen. That was excellent. It never fails. Thunderbolts never lets us down. And hopefully that will help you glean a little bit better of a picture on the super red giant Betelgeuse. It did me, and stars in general. Like I said, how can a star that's lit from its core have a black umbra in the middle of sunspots? It just doesn't make any sense. And it pretty much says it all to me. Plus the electrons that were found by Voyager and so many other things. There has to be an explanation. It can't just be ignored.
Indeed it can't, but yet it does. Every day. Get ignored. And that's much to our chagrin. Because if we could get our, if we could get our foot in the door, the electric universe becomes the queen of the sciences, everything, it will change everything, including medicine. They'll start treating us electrically, like they always should have been. But, I don't know. It's just our weird, retarded, upside-down world. I don't like that word. Okay, our upside-down, stupid world. It's just dumb, man. Come on, Greg. Where is my chatters? Oh, here you are. No, 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 not that video. That's the old video that I had showed today. Might want to watch a little bit of it. That's, no, no. Oh my goodness. That's got to be it. Ah, there you are. Hey, Dan the Tube Man, what's happening? Wow, we got some folks here tonight on a Monday night. Grouch, Greg, they all pulled the pin and went to bed. We'll drop into G Hall when you stop. Oh, okay. Well, then I guess I'll keep going. Well, I know that Polly girl, you know, she comes in and I guess she's on a tight schedule or something because she's always in a hurry. And I'm like, you know me, I like to mess around, take my time, scratch my butt, get an apple, you know, play my guitar, and listen to some essays. But let me see, who do we got here? Dan the Tube Man, you rock. Electric Circuit, the sun, or it would have flared out the Earth long ago. Well, fortunately for us, the sun is one of the most stable stars there is, and that's a good thing. However, we're not getting that brown dwarf love anymore either, so how long can we last, really? Ozymandias. The trails on the sun look like river moss. Funny how everything kind of rhymes. It does, isn't it? Everything is connected. Red Dragon. What's up, buddy? Just walked in. Marmalization. What does marmalization mean? Movie people. And it's Betelgeuse. Yeah, that was a good movie. Yeah. Ozymandias and there's Alchemy 88. Golden Thunderbolt. And you get that for hanging out the whole duration. And we have 5. Marmalization and Grouch, there he is. He's winning another one. And that's anybody else I'm missing? Shockwave was here. Oh man, you know, these guys, they quit on me every single time because I don't run right to their, like, okay, pee that way. Well, it's good to see everybody. I'm going to get back into the stuff because I ain't got anybody to chat with, and I'll start losing people. So I'm going to just get right back to the show. And Grouch, if you want, at the 1 hour mark, we'll stop her. If you guys want me to get into something else, just tell me. Saturn theory, Atlantis, giants, you know, whatever. I'm down for it all. Kennedy assassination, whatever. But I'm doing stars because whoever gets bored of stars, right? I never do. All right, I'll be back in 30 minutes because I'm not seeing anybody type anything. All right, see ya. Okay. I got to get back online here. Where is okay. Now, this one is the live stream, Greg. Okay, I got it. And this one right here is your stars. Okay, I got it. All right, I'll see you guys at the 1 hour mark. About 28 minutes. Okay. This is good stuff.
Rare stars. July 24th, 2019.
I put all my
Stars are conventionally thought to form in regions of high density. According to a recent press release from the Nobuyama Radio Observatory, astronomers detected 1,000 times fewer instances of starburst than their astrophysical models predict. Since common ideas about stars require them to form in regions where cold gas and dust are concentrated, the lack of those concentrations means there are fewer stars being formed in distant galaxies. Stars are conventionally thought to begin their lives in the collapse of cold gas under gravitational influence.
Well, you know what?
Stars are vortices
in the morning.
of compressed matter heated to fusion temperatures by pressure.
Maybe
in that view, clouds of gas and dust that are far less dense than a puff of smoke are consolidated by their slight attraction. Since the interstellar medium contains 10 atoms per cubic centimeter, on average, those clouds are scant. Indeed, the clouds coalesce irrespective of their vague structure, gradually coaxing more material into shape. Eventually, the protostar can no longer resist the inward gravitational attraction, and it initiates a self-sustaining reaction. There is a catch, however. The gas and dust must be extremely cold. Otherwise, thermal radiation generated by the friction of collapse would cause the cloud to dissipate instead of squeeze down on the star. How the cold is supposed to prevent the star stuff from heating up is not explained. If something is cold, but then it is crushed into a tiny volume, its temperature will rise regardless of its initial state. Many astronomers admit that their theories are lacking, but they are the best they have. Some of the open questions regarding star formation are illustrative of the problems. How do massive stars form? Can outward radiation stop accretion? What drives star cluster formation? Where do molecular clouds come from? Are molecules necessary? What is the role of turbulence in star formation? What causes star formation on the galactic scale? As stated many times in previous Picture of the Day articles, the electric star theory provides solutions to the puzzles and confusion so often expressed in science journals. A fundamental aspect of the universe is that it is composed almost entirely of plasma. Plasma is an electrically charged state of matter, so it responds to electrodynamic forces, along with gravity. Those wisps of gas and dust, so cherished by astronomers, are not electrically neutral. Charged particles in motion constitute an electric current that forms plasma filaments in nebulae. Electric currents are accompanied by magnetic fields that wrap around the filaments, diminishing in a 1 square root r relationship. That means that plasma filaments are probably the most powerful long-range attractors in the universe, drawing charged matter toward them, incidentally dragging the neutral molecules along for the ride. Along the strands of electromagnetically confined plasma, Bennett pinches occur, crushing plasma into tightly confined spaces. As the filaments become more narrow, the magnetic fields increase, compressing the plasma even more tightly. Eventually, the pinch effect causes plasmoids to form along the filament. Thus, stars are born. From an electrical parentage, Stephen Smith. And there you have it. Electromagnetism and celestial motion. Robert Millikan was asked whether he knew of anyone who had ever found a way of modifying or influencing the force of gravity. Millikan is said to have replied briskly, "Of course not. Such a thing is impossible and out of the question." Robert Millikan in Paul A. Lavallette's Secrets of Anti-Gravity Propulsion, Rochester, 2008. Velikovsky challenged the concept that only gravity affected celestial motions when he wrote unambiguously, "The accepted celestial mechanics notwithstanding the many calculations that have been carried out to many decimal places or verified by celestial motions, stands only if the sun, the source of light, warmth, and other radiation, is as a whole an electrically neutral body. Fundamental principles of celestial mechanics, including the law of gravitation, must come into question if the sun possesses a charge sufficient to influence the planets in their orbits or the comets in theirs. In the Newtonian celestial mechanics, based on the theory of gravitation, electricity and magnetism play no role." He further held that gravitation as an electromagnetic phenomenon. In that citation, Len E. Rose pointed out that Velikovsky had moved away from some of these positions. It should be noted that during the last 2 decades or so of Velikovsky's life, the ideas that had been expressed in Cosmos Without Gravitation, 4 Plans of the Universe, no longer reflected Velikovsky's approach to the extent that they once did. In particular, he backed off considerably from the idea of circumduction as a non-gravitational, non-inertial account, sufficient in itself to explain orbital motions. He also backed off from any general suggestions that gravity and inertia might somehow be banned from the celestial arena. He took such a pounding over it. What he often said in his later years was, not that gravity and inertia played no role, but rather that they did not play the only role. That is, that gravity and inertia were not alone responsible for what occurred in the celestial arena. Electromagnetic interactions also played a considerable role in cosmic events, especially when celestial bodies were in close approach to each other, but also even when they were far apart. In any case, each of the four plans of the universe, even the fourth, should be taken as a construction, a working hypothesis, for the purposes of discussion. Not as a final position. The same is true of cosmos without gravitation. Not all of the ideas that were formulated in that early monograph were ones that Velikovsky continued to adhere to in his later work. Nevertheless, it must be emphasized that Velikovsky did not ever abandon the idea that gravity itself might eventually be interpreted as an electromagnetic phenomenon, nor did he ever abandon the idea that the solar magnetic field might, to some extent, be responsible for the fact that the planetary orbits are roughly coplanar. This, then, is the general concept that Velikovsky believed celestial mechanics rested upon. Nevertheless, before proceeding, it must be pointed out that Robert J. Shadwald, on the advice of one of Velikovsky's disgruntled followers, brought up Cosmos Without Collision and cited it without ever letting his readers know that Velikovsky no longer agreed with much of that material, but clearly, and anger-driven, claimed these were still Velikovsky's positions. Nevertheless, Velikovsky's electromagnetic concept is now out in the scientific community, and as we will see, it is growing. As was also pointed out above in the chapter on celestial mechanics, there are several aspects of celestial mechanics that cannot be correlated mathematically without Newtonian theory, but require an additional force, electromagnetic force, in order to operate. Miles Mathis, who well understood the depths of maniacal rage this Velikovskyan concept held for his critics, pointedly states, astrophysics, who would have to admit that Velikovsky was at least partially right, would rather tear out their eyeballs and eat them than go there. In terms of Freudian psychology, the great underlying neurotic problem of humanity is the Oedipal complex, as outlined by the Greek playwright Sophocles in his trilogy Oedipus. Oedipus, unable to deal with the fact that he had violated every moral aspect in his life, when discovering that he had actually done so, gouged out his eyeballs, unable to face his behavior. So too the scientists of this generation, according to Mathis, rather than admit Velikovsky was at least partially right, would rather tear out their eyeballs. Velikovsky was related. I'm just picturing that. Velikovsky has related a story he liked to tell. Once in the twilight hour, a visitor came to my study, a distinguished-looking gentleman. He brought me a manuscript dealing with celestial mechanics. After a glance at some of the pages, I had the feeling that this was the work of a mathematical genius. I entered into a conversation with my visitor and mentioned the name of James Clerk Maxwell. My guest asked, "Who is he?" Embarrassed, I answered, "You know, the scientist who gave a theoretical explanation of the experiments of Faraday?" "And who is Faraday?" inquired the stranger. In growing embarrassment, I said, "Of course, the man who did pioneer work in electromagnetism." "And what is electromagnetism?" asked the gentleman. "What is your name?" I inquired. He answered, "Isaac Newton." When Velikovsky awoke, on his knees was an open volume of Newton's Principia. This story is told to illustrate what I have said before. Would you listen to anybody discuss the mechanics of the spheres who does not know the elementary physical forces existing in nature? But this is the position adopted by astronomers who acclaim as infallible a celestial mechanics conceived in the 1660s, in which electricity and magnetism play not the slightest role. Let us first examine the reaction of the astronomers to evidence that electromagnetism plays in celestial mechanics, before looking at the experimental evidence related to it. This brings us the first part of the Velikovsky affair, when critics of Velikovsky's concept that electromagnetism plays a crucial role in celestial mechanics was debated and forcefully denied. What we will see is that in each and every instance, when a critic leveled a charge against Velikovsky's electromagnetic concept, and it was shown to be an error, and further the evidence instead supported Velikovsky, the critic never faced up to that counter-evidence and acted as if the counter-evidence never existed by retreating into a state of silence and denial. Let us now look at these early critics
I
and
know
the
another
evidence.
person that's
The first
just like
critic
that.
was Donald Menzel, director of Harvard College Observatory, as explained by Ralph E. Juergens. In 1952, in the Proceedings of the American Philosophical Society, Menzel had offered calculations to show that if Velikovsky were right about the electromagnetic forces in the solar system, the Sun would have a surface electric potential of 10 to the 19th, 10 billion volts. An absolute impossibility, according to the astronomers. But in 1960, V.A. Bailey, emeritus professor of physics at the University of Sydney, claimed that the Sun is electrically charged and that it had a surface potential of 10 to the 19th volts, precisely the value calculated by Menzel. Bailey, at the time his theory was first published, was entirely unaware of Velikovsky's work and of Menzel's refutation of it. The idea that this quantitative refutation of Velikovsky's wild hypothesis, Menzel's own description
was just
of
a
his
bitter
contribution to
little
the
man.
Proceedings in 1952, should now be brought to Velikovsky's support, was intolerable to the Harvard astronomer. So when he mailed his paper to Harper's in 1963, he also sent a copy to Bailey in Sydney and asked him in a covering letter to revoke his theory of electric charge of the Sun. The theory was casting doubt on the continuing efforts of Menzel and other American scientists to discredit Velikovsky, and Menzel pointed out of what he conceived to be an error in Bailey's work. The mathematical error, to the contrary, had been made by Menzel. Nevertheless, when new scientific evidence supported Velikovsky's concept regarding electromagnetism, neither Menzel nor the rest of the astronomical physics establishment jumped at the opportunity of evaluating how it might operate, but instead tried to deny the evidence existed. Einstein agreed with Velikovsky, who said, "The real cause of indignation against my theory of global catastrophes is the implication that celestial bodies may be charged." He, Einstein, wrote in the margin, yes, just like the scholastic professors denied that Galileo's telescope showed Jupiter had 4 moons circling it. The entire scientific establishment denied that the Sun may very well carry a charge capable of affecting the orbits of the planets. There was no investigation, only flat-out denial. The second astronomer who criticized Velikovsky's electromagnetic concept in the early part of the Velikovsky affair was James Warwick, who specifically wrote a paper on magnetic stars that, like Menzel's, was supposedly a devastating calculation in rebuttal to Velikovsky. He claimed that the astronomers had been working with magnetic star motions for years, and found nothing to indicate their high magnetic fields had any influence on motion in this regard. The original criticism appeared in Chronos, Volume 10, Number 3, 1985, pages 10 and 11. My answer to Warwick was published 3 years later. Immanuel Velikovsky claimed that 2 magnetic stars orbiting at close quarters would not be influenced by gravitational interaction, but also by magnetic interaction. Earth and Upheaval, New York, 1955, Forum Address, page 297. Radio astronomer James Warwick calculated the influence of 2 magnetic stars, each of 10,000 Gauss, separated by 3 solar radii and aligned with their dipole moments, directed toward each other to maximize the magnetic interaction. Based on his careful calculation, he could claim that the magnetic interaction between the magnetic stars was about 1 billion times smaller than gravity, far too small to influence the orbits of these bodies. We wish to challenge this conclusion, based on mathematics and physics, and offer observed evidence that denies the validity of Dr. Warwick's calculation and conclusion. The third instance of the early Velikovsky affair, wherein a critic attacked Velikovsky's concept that there was an electromagnetic force in addition to gravity operating, is Ivan King, an astronomer and one of the organizers of the 1974 AASSS Symposium on Velikovsky, who bluntly stated before the meeting was even held, "What disturbs the scientist is the persistence of these views, in spite of all the efforts that scientists have spent educating the public. It is in this context that the AASS undertakes the Velikovsky Symposium. Although the symposium necessarily includes a presentation of opposing views, we do not consider this to be the primary purpose of the symposium. None of us in the scientific establishment believes that a debate about Velikovsky's astronomical electromagnetic force views would be remotely justified at a serious scientific meeting." Strangely enough, King's research deals with the behavior of globular clusters that are spherical in shape and are made up of 10,000 to 1 million, mostly old red giant stars. There are a few hundred globular clusters in the Milky Way, with the greatest concentration of stars toward their central cores. Also unusual is that these globular clusters do not revolve about the galaxy as do the stars in the galactic disk. on relatively circular orbits. Rather, these clusters have orbits that are highly elliptical, like those of most comets in the solar system. Globular clusters orbit toward and away around the galactic core. Furthermore, the orbits of the stars in these globular clusters do not orbit its core in circular orbits, but do so in orbits that are highly elliptical. This creates a major gravitational problem in explaining how these clusters can survive. Over time, stars will approach one another and gravitational interactions will accelerate one of them so greatly that it will leave the cluster forever. Therefore, these globular clusters should be shedding members and becoming ever smaller in size. However, when a star is kicked out of the cluster, it will remove gravitational energy or angular momentum with it and make up for this loss of gravitational energy. The star that interacted with the escaped one must move inward to counterbalance that loss. The law of conservation of angular momentum is fundamental to gravitational theory and demands this. Therefore, because the globular cluster is now somewhat smaller in size, the stars in it left behind will move closer to one another and will then repeat the interaction process again and again, sending stars out of the cluster while the cluster continues to contract. But for some reason, this law of gravity is not working in these globular systems. King well understood this fundamental contradiction to gravitational theory and admitted this. Now, this not only relates to the hundreds of globular clusters in the Milky Way, but to the billions upon billions of other spiral galaxies with globular clusters throughout the universe. In other words, celestial mechanic equations cannot account for the failure of these fundamental laws to work as they should throughout the universe. Here, then, is how King dealt with this massive negation of the theory he claims disproves Velikovsky. Although globular clusters are obviously long-lived, they are not immutable. Slowly but steadily, stars evaporate, escape from the cluster as they reach escape velocity from the cluster during their interactions. The gravitational theory that adequately predicts the resulting evolution of the cluster is basically simple, but many of the details have remained elusive. The binding energy of a cluster holding it together is really an energy deficit, the energy it would take to accelerate all the stars to their escape velocity and tear the cluster apart. To reach escape velocity, a star must acquire enough kinetic energy to overcome the cluster's negative gravitational energy. Thus, the stars that escape are those with the most kinetic energy, whereas the amount of gravitational energy they contribute to the cluster is no more than average. As a result, the evaporation of stars increases the amount of binding energy per star remaining in the cluster as the cluster contracts. According to the current theory, it does not reach a steady state. Instead, energy from the contraction of the cluster is converted into kinetic energy of stellar motion, thereby heating the core. The core becomes more dense, and the stars in it near it remove more rapidly. Therefore, more stars evaporate, and the core continues to contract and heat without bound until it is infinitely dense. Donald Lyndon Bell, proponent of the theory, has dubbed this positive feedback phenomenon of the gravitational catastrophe.
Talking about brown dwarfs, if a brown dwarf gets close to a very bright star, the bright star is at a higher potential than the brown dwarf. That brown dwarf will actually switch off as a star and become a comet. It switches from being an anode in the discharge system to being a cathode, and there are quite distinct differences. Now, if the Earth, hypothetically here, if the Earth was a satellite of a brown dwarf, that radiating shell would be quite enormous. It could have all of the satellites of that object, that small star, orbiting within that envelope. That whole radiating envelope puts energy on the surface of any orbiting planet equally on every square metre. So that you would have no seasons, no day and night, and you'd receive ultraviolet light. This refers to what Dwarfs was talking about the other day with the earliest memories of mankind. It suggests that we were in this situation, and astronomers in recent years have come to the conclusion that this is the more likely place for life to thrive. Where we are now is much more precarious. So brown dwarfs don't hang out with stars because electrically it's impossible. The other thing is that these brown dwarfs, unexpectedly, they flare. They throw material off occasionally because they've got no means of controlling their discharge other than to get rid of material, matter, charged matter. So that any satellites of these brown dwarfs gets occasionally drowned in water, an atmosphere, and also solid materials to cause layering on them. Brown dwarfs flare and deposit layered minerals on their satellites. There's a few more logical leaps involved in the electric universe, and I'll just go through a few of them. I asked the question, is gravity a weak electric dipole-to-dipole force between distorted subatomic particles? And this refers to something that Velikovsky said to me when I visited him, and also to Ralph Sainsbury's view that all subatomic particles have an orbital structure, a resonant orbital structure. And as Ralph has pointed out, magnetism then is also an electric dipole-to-dipole force due to transverse distortion of electrons or protons accelerated in an electric field. If so, the electric force is the only force necessary in physics, and this goes back to the way classical physics operated by trying to reduce the number of forces and ideas. And quantum effects imply that all matter has a resonant electrical substructure. Information and energy can be stored and transferred via these matter resonances, and that has significance in biological systems too. So astrophysical and biological coherence requires universal, near-instantaneous electrical interactions. All of the so-called spooky quantum things are no longer spooky if we accept this idea. We have a return of the ether. We must have particles to be able to transfer the energy and the forces through so-called empty space. Empty space, I suggest, is full of neutrinos. Neutrinos are the lowest energy state of matter. They exhibit vanishingly small mass. They're composed of subtrons, which is what Ralph called them. They form electric dipoles, that is the neutrinos, in an electric field, and each dipole rotates in the electromagnetic field of a light wave that ties the speed of light in a vacuum to the moment of inertia of a neutrino. And neutrinos may reintroduce cause and effect to radioactive decay. At present it's a purely statistical phenomenon. The other thing is that it also solves the difficulty of the so-called annihilation and creation of matter in particle accelerators. You cannot do it, but if the neutrinos are the substrate, they can accept energy and become a particle and its mirror particle. I don't use the word antiparticle because there's no such thing. It's all matter, normal matter. I put these few slides on the end because there was discussion about Venus and the transfer of charge, and I think it's important because it returns Velikovsky's gauntlet to him cordially. Velikovsky argued that planets change orbits, exchange thunderbolts and quickly settle into peaceful orbits. Now, rapid settling after chaos defies Newton's laws, which, of course, that was the argument levelled against Velikovsky, which for more than a two-body gravitational system are chaotic anyway, so the astronomers have yet to explain why we have a stable solar system. So astronomers simply ignored the gauntlet flung down by Velikovsky. Then we have Anthony Peratt and the convergence of his work with ours some few years ago. And he showed, globally, petroglyphs show to a high degree of confidence that within human existence the Earth has suffered stupendous electric discharge phenomena from the heavens. And that's a picture of one of his papers. Now, if we accept Velikovsky's gauntlet, we need to look at Newton's law of gravity again and just have a think about what it really means. You'll notice there that G, I put its dimensions there just to show that it does include mass, and if mass is a variable, then we have a problem. It is simply assumed that G is the same for all bodies in the universe. In other words, the universal gravitational constant.
Come on, join me.
An assumption. Stellar and planetary structure and composition is based upon this premise, but if mass is a variable, can it explain cosmic pool? The book over there is by one of the Thunderbolts team, C.J. Ransom, The Age of Velikovsky. Of course, MOND is the latest buzzword in gravity theory, the modified Newton's dynamics. I've suggested that we can have electrically modified Newtonian dynamics. And I won't go through all that business there, you can see it on my website and so on. But the upshot is that the radius of the orbit of the planet is proportional to the mass of the planet if you keep the orbital energy constant and you assume the sun's G is constant, and I think that's a fair assumption. If the mass doubles, the orbital radius must double to conserve orbital energy. Now, I said earlier that all planets and stars and all celestial objects will form an electret. In other words, you have positive poles facing inwards and negative poles facing outwards. So it sets up an internal electric field. The planet acts like an electret. And any free electrons would tend to drift towards the surface. Like a subatomic particle under the stress of an electric field, the internal electrical stress modifies the apparent mass of the planet or star. And therefore
Yes, I'm okay.
Exchanging charge at the surface through lightning, etc., changes the mass or gravity of a planet. And there is evidence for that. Coronal mass ejections, large ones which strike the Earth, actually change the rate of spin of the Earth suddenly, and then it decays back to its original speed, which is diagnostic of a change of the moment of inertia of the Earth by some means which hasn't been explained. Comet accelerations also. Cometry displays an obvious electric discharge phenomenon. Any body on an eccentric orbit about the Sun will experience discharge activity. The discharge will cause apparent non-Newtonian acceleration, and this is well known with comets. They're very hard to predict their precise return because of them. And this is because the mass of the comet is changing. So
I'm going to stop it because we've seen that many times. We've seen it like 2 or 3 times, and it's really good. But that part we've seen, I don't want to get redundant. We'll just move maybe up a little, and maybe we'll do a little Saturn Theory 2. Oh, yeah, this is good. We'll come back on this. Grouch is going to join me, and I'm going to put on some tunes, get some pictures going, and then we'll have a little chat maybe, if you guys want to. I'll come out there in a second. I just want to get my picture show going first. So I'll do this. Okay. What to play. Oh, let's hear something from my Discord buddy. He's got a little band, and man, they're pretty damn good. I keep saying I'm going to get him in, and then I keep forgetting. So I'm going to get him in and keep my word. Okay. Nothing I hate more than people that don't keep their word. I know somebody like that. Where is it? Hey, St. Pauli Girl's still on. The Deuce is on. Felix Coconuts, Baked and Awake. Archibald. I got a lot of my peeps on, man. Where are you guys all at? It's okay. I understand. I was late. I dragged my feet. I shouldn't have. We'll get together and maybe record it if I have to. Dogstar. Yes. And is this? Yeah. He's got himself a little band here, and I don't know which song to pick, so I'm just gonna go ahead and. I think number 4 was. I heard it before. It was pretty cool. Number 5. Oh, there is no number 4. It goes from 3 to 5. We'll go with song 1. Get an elephant chain. Heavy.
Taking away your sinister spoon. addiction will fight. Side effects conditional blow. You feel you're losing your mind. Progress in your failure to live without it. Live without it. Breaking out the money that chains you to your suicide. Now the chain gets stronger. Can't
What do you think, Andy? Grouchy, you there? Did I put you to sleep? I had to
No.
get. Oh, I had to get a proper soul adjustment. That's why I put on the less mellow song. Settle down a little bit, you know.
All right.
So what's going on?
Oh.
Anything good?
No, not really much.
No.
Cool over here. Hey, you keeping an eye on the chat?
Yeah. Well, you know, I'm open to whatever. You know, I figure if you want to chat, it might be cool. What do you want to chat about?
Yeah, no, I was just having. Oh no, I was just having a look through here and saying everyone chatting away.
Oh, good. Yeah.
Yeah.
Yeah. You know, it's the one thing that I told you I want to start incorporating a lot more of that into the show because that's a big part. And we're not taking advantage of it. We
Yeah.
should because everybody's got a good, you know, we got some good heads out there. And like I said, now
Yeah.
with the stars, remember when I was asking you about, or everybody, it's like, okay, well, we got, see, this is the only thing that I really need. I don't really understand how it works. Maybe somebody does. I don't know that's out there. But when you got the Birkeland currents connecting the stars,
Yeah,
and maybe
well-
they don't really know, but now, do they only go like down or would they go back up? Or like if a star becomes a red giant, say, it was a sequence star like the sun, and all of a sudden its power got zapped and it became a red giant, because that can happen. That's what happens, right? It doesn't necessarily have to be a white giant, a red giant. It could be a white dwarf, but it just depends. Now, if something like that happens to a star, can it go back ever, or is it always going to be at that or worse? That's another thing I'd like to know. Yeah, I'm behind the live broadcast.
Keep
Are we
moving
close
forward.
to be done? Yeah, we. Well, I don't know. You see, where are we at? I don't even, because I don't pay attention to the clock. I'm like that. Did you ever see Easy Rider in the beginning? He throws his watch down. That's how I am. I'm that guy when I live stream. I throw my watch away.
Look at that. Alpha likes your graphics.
2 hours and 15 minutes. I
Alpha likes your
I was planning on going for 3. What'd you say, Andy?
Oh yeah.
So we got
Alpha likes your graphics.
yeah. I'm a visual kind of guy.
Renegades on.
Yeah,
Yes.
I like visuals. You know.
Yes.
Because you know, I can settle for words. It doesn't matter to me, because I know a lot of people who do presentations with text. That's fine, but a lot of people don't like it. They like to look at cool stuff, you know, like that right there. That was the galaxy that ARP discovered, connected with filament. They got 2 different redshifts. The other one was Markarion. And that right there, I don't know what the heck that is. Why is that small? Shouldn't be small. So, you know, I tell you, were you the one that showed?
Like to talk on Discord, Greg.
Huh? What?
I wonder if there's anyone in the chat who'd like to talk on Discord.
Well, I don't know, but
They
I was
all
going to ask you a
they
question
all
first.
signed up.
I was going to ask you a question first.
Go.
Was it you that
Yeah.
showed me the Mungo Jupe video this morning? You were the one, right? When we were watching Rich Planet, and they were talking about they were seeing UFO wars, right? And I'm like, man, how can that
Yes.
be? How can that be anything else? And you're like, well, check this out, and it pulls it out of his butt, and I watch it, and I'm like, my jaw hit the floor. I never knew that those things could do all that, act like they're intelligently controlled, and I mean, like, of course it's plasmoids, has to be now, you know. So I'm gonna put the
Yeah.
folks. I'm gonna put the folks on the telly. Okay, there we go. I want to say hi to everybody. Well, I appreciate that because
Yes.
I came away with a completely different point of view. Now I don't have to accept aliens.
Well, that's
Because
what
really, the
Thornhill-
thought of aliens
that's
crawling
what-
over.
well-
Go ahead.
Well, that's what Walt Thornhill and that talk about with the plasma and the electric universe and that.
But the plasmoid.
Basically, it is, and you know, all those lights and that. You
Did
know,
you-
like I tend to think people like the idea that they're little green men, but I don't know.
No, I don't like that idea either. But I mean, you know, it could both be happening. I don't know. I never scoff at anything.
Oh, it's true.
But
Yeah.
you know, it's almost like a woman scoffing at a man because he's getting a little pension check, and then for the woman to 2 years later that scoffed at him try to take it from him. Almost kind of like that. Yeah. But
Yeah, I'll copy
anyways,
the link to that Mungo one, Greg.
the
That
link.
Peter Mungo one.
Yes.
I'll copy the link and put it, and I'll put it in the chat.
Well, you know the video I just
then you
premiered.
do
It's
that.
in the description of that video,
Oh yeah.
so you can get it from there. I'm looking for it
Yeah.
right now, and I'm going to
Yeah,
get it
yeah.
for people, and then here, right here.
I think I got one.
I'll get it for folks. And I mean, it was only like a 14-minute video, but it helped change my view. Now I don't have to accept aliens, and it's not that I don't want to accept them. I don't really like the thought of them crawling all over my planet. But you know, I mean, some of them stories, you know, you go, God, I mean, how can it be anything else? But then this comes up and it goes bang, slam, wham, bam, thank you, ma'am, and it's plasmoids. Yes. Okay, so that really makes me feel a lot better. So anyways, here is I'll put it in chat. You guys copy it and save it. Don't leave me to watch it. But there it is. I was going to watch the video we premiered next, you know, after we chat.
Yeah, you even done about than me.
You know, I don't really know what to think, to be honest with you. I just keep my eyes open and my ears believe nothing I hear and half of what I see, right? But sometimes you gotta wonder. You just gotta wonder what's going on out there. You know, but I think that you know, there's this thing where Obama's on Jimmy Kimmel, you know, and he starts talking. He said, the first thing I do, my hand would be hot off the Bible, and I'd be running down to find out the real deal on UFOs. And Obama says, that's why you will
Well,
never
Donald
be
says
president.
they come from inner Earth, and that's basically what Peter Mungo's saying.
Extraterrestrials, not aliens. That's what I'm hearing. That's what I'm thinking.
No. Yeah,
They're survivors,
yeah,
right?
yeah, but we can't live underground long.
No, you were saying that, and I think that I heard that somewhere else before too. That human beings cannot replicate underground. I don't know if it's true or not.
No, oh well, I don't know about that. But our lungs and that,
Yeah, we need to get out.
our lungs
yeah,
and that can't.
Yeah,
I mean,
we're not meant to live
Sure,
underground.
we're-
I don't think so either. I think that it would drive
we've
us
got
absolutely
to have
nuts.
light.
Hey, I have to hit the little boys' room. So you want to entertain the folks? I'll be right back.
Oh, thanks, Greg. Isn't it? To many to be a non-invasive species capable of space travel without ships like mushroom. Yeah, that's a good idea. Renegade. He could have put a video on, couldn't he? What else have we got here? The strong. So it's a bit hard to talk the blank screen, isn't it? But anyway. Greg, the ancient Romans had a story of apparatus burning shields, wandering. Rome had lots of good stories, didn't I?
She's got a college, man. I know. Yeah, so I went and tore him up today in court.
Well,
I didn't keep my mouth shut. I just kept barking because I was going to outbark her.
How'd
She
you
wants
do,
to
Earl?
bark, 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 bark. I got my way because I was right.
So you did all right.
Yeah,
So you did all right.
yeah,
Well, that's good.
yeah.
That's good. So see here where normalization, he says, Greg, ancient Romans had stories of apparitions of Cybele dentes, burning shields wandering in the sky.
Where are you reading that?
Well, that would again be
Where are you reading that at?
on the chat.
Where
on the
at?
chat.
Is it high, low?
Top chat. Down the
Top?
bottom.
Down in the bottom?
Right down the bottom. Just been put on. Just
The
been put on.
ancient. Okay, yeah.
Yep.
Well, like I said, man, it's very possible. I think that there is more to the Nomo story than the Anunnaki. I was watching that this morning with Johnson and Rich Planet, right? And they're right. I agree with them. They're right. I think the Nomo are a lot more believable because they're fish people and we are like aqua apes. So it makes more sense than the Anunnaki thing to me. But that's just to me, because how else would those Dogons know all that stuff? They knew Saturn had rings. They knew that, well, that's because Saturn was close, right? And they knew that Sirius had a dark star, and then there's supposed to be a third one. I don't know if they found it yet or not, or maybe it has a planet, something like that. And there's just so many things that they knew, and I think they were talking about how many particles there are, and they guessed around 200, and that's what I think science is at right now. So it's pretty crazy. How would they know that stuff? It's kind of wild. Now, certain scientists started lying and saying that they were schooled by some that's just baloney. They just don't have an answer. So when they don't have an answer, they do the next best thing. They lie. But you know what? I mean,
where are you hiding? Yeah, keep going, Greg. Keep going.
It's the only place to hide when cosmic lightning. Yeah, right. Down in the earth. Well, obelisk. Yeah. A lightning rod. I remember as a kid, seeing that big iron bar sticking out of the roof of the well or something. It was. What is that? My dad said it's a lightning rod. I never forgot that word.
Right
Every time I'd go to a house, I'd look for the lightning rod. Where's it at? It's got to be somewhere. They don't have them no more. But the older houses did. They had milk chutes. You don't see milk chutes no more for the milkman.
Well,
Yeah.
he doesn't deliver anymore.
Milkman would come around with his milk.
Yeah.
Cream would be on top, orange juice, cottage cheese, Milkman Day was a good day when you were a kid. How did we get talking about that? I don't know. Oh, you see that picture right there? That's that statue in Afghanistan, right? That's on the screen right now?
Yes.
Now, didn't they blow that up?
Yes, it's just come on now.
Yeah. Didn't they blow that up?
I'm not sure, but I know a lot's been blown up.
Yes. They were copper and green from corrosion. Yes. Mm-hmm. If they were struck, I would imagine. Or did that just come from the,
No, the copper goes green. The copper goes green after a
Yes, it
while
does.
through aging, and
Yes, it does.
and you get that bit of electric. So modern day, you have on your house, you have those trip circuits that if they notice any back current, they just trip before you get a short. That's the idea.
Yeah, well, anyways, in that...
So lightning rods
in
will
that,
take all that.
Yeah, but do they attract the lightning? Is that when the lightning strikes the house, it'll be attracted to the lightning rod? That's probably the way it works, right?
I need Donald. Milkman has too many kids.
It does, the milkman's son, yeah. I was going to ask you a question. You made me forget.
Well, you say it's the simplest path to Earth. That's the idea of it.
Mm-hmm. Oh, I see. So
and takes the grunt of the voltage.
Right. It
so if you build an electric fence,
keeps you safe.
If you build an electric fence, you put off an electric fence a cable to a ground.
Mm-hmm.
So if the fence gets hit by lightning anywhere, it's meant to take the brunt of it instead of burning out the fence unit.
I see.
Yeah.
I told you I had a tree in my backyard struck by lightning. It put a big scar in the tree, hit the cyclone fence, ran down the cyclone fence and slammed into the side of my garage and tore a hole in my aluminum siding.
Yeah.
It was powerful, man. That was the only time I've ever been that close to a lightning bolt, and it was just like, pow! And it's like really bright, and it's like, oh, what just happened? You know, it'd probably be like what a nuclear blast would be like, something like that. Because it wasn't.
It's a massive bang.
Yeah, you didn't hear nothing. It just, pow! You know, it's like as loud as it could be, man. Ear shattering. And I was like, you all right? You all right? What just happened? You know, kind of gets you a little senseless when you're that close to it.
Yeah, Gerald, they used to be filled on the inner tube with lead, didn't they? Those lightning cores that you used to put in the ground. Weren't they copper on the outside and lead on the inside?
I thought they were iron.
Does that sound right, Greg?
I always thought they were made out of iron. I don't know.
Well, they could have been too.
Mm-hmm.
Yeah.
Yeah, and then
But iron would corrode.
when I was
The
a
iron
kid,
would corrode pretty quick.
I still remember a time when people had outhouses. I was a little kid, you know, to go to the bathroom. Everybody had an outhouse in the country, you know.
Yeah.
But then they finally got
Yep.
septic tanks. You know, those things are nasty. I almost got a job once, and when I found out it was cleaning septic tanks, I just kind of walked away from that one. How you get to drive a nice truck? Yeah, okay.
You weren't too keen on that.
Huh?
Yeah. You weren't too keen on pumping crap.
No, I wasn't down for that. No. Mm-mm. No. Because remember Patton, he says, when you're sitting your little grandson's on your knee, say, "Oh, it was a great war. Granddad, what did you do?" He goes, "Well, you won't have to say, I shoveled shit in Louisiana." Right? That's what he says. Big American flag. When you put your hand in a bunch of goo that used to be your best friend's face, you'll know what to do. Yeah, it sucks all the love out of you. It turns you into a zombie, a killer. But you know what? A lot of good people can overcome that. You know, they just know they have to, and they do what they have to do to overcome it. But there are many folks who can't rise above that, and they end up addicted to drugs, and it's sad. You know, I don't think that the medical facilities take care of our veterans like they should. They should get premier care for just putting their life on the line. That's the way I see it. It's not like they have a choice, you know. And they're doing it really. I think our Army is what 90, or is it 100% volunteer? No, they don't draft anymore, do they?
He says like ours, they're not drafted.
No.
But don't they con the young ones with the if you join the forces, you don't pay for your college education.
Right. You get free college.
Isn't that one of their?
That's the lure.
Isn't that the big bribe? That's the big bribe they use.
Many people have made their life better by joining the military. I understand that. What I mean is war. People that go through war, when they come back out, they're not.
Yeah, well, the trouble is you join it.
Mm-hmm.
You join it to get cheap education, and then you find out you get sent to somewhere like Afghanistan, and the education all of a sudden is not that cheap, is it?
No. And it's just not worth it.
Yeah.
I don't know how many times I see our guys get pinned down and they're calling for air support and they can't find any. They can't get any. What's up with that? I thought we had the most powerful army in the world. It's just loaded with helicopters. Every time they're in Afghanistan, they get pinned down or something. They can't. They play hell trying to get air support. I always wonder, why is that? You know, what's going on? But you know, I guess that's what it is. It's they wouldn't put the ones on that are easy. They just put the ones on that are, you know, there was a problem, right? They overcame it. Those guys on that hill, oh man, that was just brutal.
So Gerald, when you made the spears, did you use a spirit thrower to throw them, or did you just throw them like a javelin?
The price today.
You look in the chat.
Yeah. Oh, okay. File to play with the 60s.
Was built. So copper was not in demand today. Yep.
I've seen 12-foot board blown out. 1885. Oh, yeah.
Yep. Same with Greg. What do you reckon? We play a bit more? Play another video? What do you got lined up?
Well,
next?
you know what? I kind of, well, I could go back to the stars, but I was kind of wanting to watch that video from tonight again because I really haven't gotten a chance to watch it. When it played during the premiere, I was busy. You guys don't mind with that?
Well, do it.
It's only 18 or 20 minutes long. All right, we'll get back to it because I'm boring here. I don't know. But I do have a good subject to talk about when we get back. All right?
No worries.
All right, we'll talk.
Right,
I'll see you guys
go.
in a little bit. All right. I know, I get to babble.
See you soon.
Okay. Bye.
It's your show.
Yeah. All right, I'll be back.
See ya.
Record-breaking flare from nearby Proxima Centauri. Astronomers saw Proxima Centauri, the star nearest to our sun, emit a flare or burst of radiation 100 times more powerful than flares from our sun. They said Proxima's flare ranks as one of the most violent seen on a solitary star anywhere in the galaxy. As the current sunspot cycle, cycle 25, revs up, we can expect our sun to become more active in the coming few years. And that means more solar flares, or bursts, of radiation on our sun. But the flares on our sun can't compare to those on Proxima Centauri. That's 100 times more powerful than any flare seen coming from our sun. They said the flare ranks as one of the most violent seen. Little Proxima Centauri is a faint red dwarf star. It's usually considered to be part of the star system of Alpha Centauri and is only 4.2 light years away. Since red dwarfs are common and tend to have mighty flares, and since the flares might or might not adversely affect the chances of life forming on planets orbiting red dwarfs, these astronomers said their study might help shape the hunt for life beyond our solar system. The peer-reviewed astrophysical journal Letters, published this new study on April 21st. Astrophysicist Meredith McGregor of the University of Colorado, Boulder, led the research, in which astronomers observed Proxima for 40 hours in 2019 using 9 telescopes on the ground and in space. McGregor said that Proxima went from normal to 14,000 times brighter when seen in ultraviolet wavelengths over the span of a few seconds. Proxima's powerful flare was seen across the entire electromagnetic spectrum. Isn't that interesting? The astronomers said this is the first time that a single stellar flare, other than those that occur on the sun, has been observed with such complete wavelength coverage. We had never seen an M-dwarf flare at millimeter wavelengths before 2018, so it has not known whether there was corresponding emission at other wavelengths. The study was precipitated by a serendipitous discovery of a flare from Proxima Centauri in 2018, archival data, from the Atacama Large Millimeter Submillimeter Array, ALMA, a linked array of 66 radio telescopes in northern Chile. Afterwards, McGregor's team coordinated an effort to observe Proxima, using the ALMA telescope and other telescopes on Earth in space. In May 2019, the effort paid off when Proxima Centauri ejected its violent flare, which lasted just 7 seconds, but generated a surge in both ultraviolet and millimeter wavelengths. The flare was characterized by a strong impulsive spike never before seen at these wavelengths. The event was recorded by 5 of the 9 telescopes involved in the study, including the Hubble Space Telescope, HST, in ultraviolet, and ALMA in millimeter wavelengths. Powerful flares from our Sun may happen only a few times in an 11-year solar cycle. McGregor compared the flares on Proxima Centauri, saying, Proxima Centauri's planets are getting hit by something like this not once in a century, but at least once a day, if not several times a day. She added, if there was life on the planet nearest to Proxima Centauri, it would have to look very different than anything on Earth. A human being on this planet would have had a bad time. I thought I was going to say bad day. Bottom line, astronomers saw Proxima Centauri, the star nearest our Sun, emit a powerful flare, or burst, of radiation. They have to repeat themselves now, because they're out of things to say. In May 2019, Proxima's flare was 100 times more powerful than our Sun's flares. They said Proxima flare ranks as one of the most violent seen on a solitary star anywhere in the galaxy. I think that they said that 3 times. I don't mean to be a smarty pants, but, give us some facts. Give us some facts that we can dig our teeth into. That's all I ask for. Well, I couldn't find anything from the electric universe on Proxima Centauri, but to give you an idea on electric stars, I found this, and then another article after it from a different website. Stars are electrical, and they evolve according to the laws of plasma physics. Every circuit which contains an inductance is intrinsically explosive. Every circuit which contains an inductance is explosive. The inductive energy can be tapped at any point of the circuit. If we try to interrupt the current, the inductance tends to supply its energy to the point of interruption, where the power is delivered. This means that most of the circuit energy may be released in a double layer, and if large, it can cause an explosion of the DL, Hans Alfvén. A recent picture of the day discussed the way that a supernova explosion occurs in an electric universe. Instead of the traditional explanation that involves gravity and core rebound, supernovae are short circuits in a star's capacitive attribute. Electric flux from a galactic power generation builds up until the accumulated charge overcomes a star's dielectric insulation, causing the energy of a vast interstellar circuit to focus at one point. A nova explosion, on the other hand, is something completely different. Conventional theories state that gravity is also the culprit, except that there is no detonation of an entire star. According to a recent press release, when a white dwarf star accretes too much material from its companion star, it ejects material. The previous picture of the day points out that binary star systems are probably the most common in the Milky Way. The explanation for those configurations, stellar fissioning. Since a star's primary electrical activity takes place on its surface, if electric charge flow from the galaxy increases beyond a certain point, a star might divide into 2 daughter stars, increasing the surface area, as in Solaria Binaria. That's exactly what happened, according to de Grazia. 2 stars in orbit within a space charge sheath are able to accept more electric flux. However, consensus theories about star birth and evolution maintain the binary stars begin life as two cocoons, close to each other inside a protoplanetary nebula. As the nebular propylids contract over time, depending on the amount of material in their accretion disks, they might develop into two different kinds of star. Nova theory depends on that idea. One type of star is the aforementioned white dwarf. White dwarfs are said to be quite hot. Some of them exceed photospheric temperatures of 100,000 Kelvin. Astrophysicists think that if a newborn star possesses an exceptional initial mass, it will be so hot that it will quickly exhaust its primary hydrogen fuel and collapse under its own gravity. White dwarfs are therefore hot and dense with high gravity. If a white dwarf star is in orbit with a larger companion, it is said that it will draw stellar material away from the larger star onto its surface. Astronomers believe that its high gravity compresses the gas and dust against its rigid geodetic surface until it reaches fusion temperature. At that point, pulses of high-frequency light and powerful shock waves erupt into space like a bomb going off. Another way to see these events is to consider electric charge flowing through plasma. As charge flow increases, it generates an electromagnetic field that constricts the current channel. As pointed out in the previous Picture of the Day articles, that constricted channel is called a Bennett pinch, or Z-pinch. Those channels, filaments, form double layers with large potential voltages. Electric forces in double layers are far more powerful than gravity. Double layers can explode, releasing more energy than is locally present. That effect is seen in solar flares, as well as in nova explosions. Novae could be thought of as coronal mass ejections that involve an entire star. When photospheric double layers expand, that expansion accelerates charged particles that are crossing it, causing collisions with neutral atoms. These collisions show up as gamma rays, X-rays, extreme ultraviolet light. Expansion into surrounding plasma generates shock waves. Yeah, I know that guy. But those waves are driven by a surge. They are not stellar H-bombs going off. Just as the solar wind accelerates beyond the sun's surface,
half a swastika.
nova waves, which you know is a current, nova wave fronts continue to accelerate, where ballistically driven explosive debris would slow down. Exploding double layers are responsible for nova phenomena. Steve Smith. And we have another one here. This one is a little bit, it makes you think if there was perhaps some kind of living beings living on one of the planets for Proxima Centauri. Maybe not, but this is intriguing. Did Earth receive a radio transmission from Proxima Centauri? This is dated January 20th, 2021. A team of astronomers is hard at work analyzing an unusual radio signal detected in early 2019 by the Parkes telescope, a 64-meter radio dish in eastern Australia. The signal appears to have come from the direction of Proxima Centauri. There's a lot of stuff in Australia. Did you notice that? I'm probably wondering, is it because of the southern hemisphere? It has to be. The signal appears to have come from the direction of Proxima Centauri. Proxima Centauri, the nearest star to our solar system, and its characteristics are more typical of an artificial broadcast than a natural radio source. Maybe they were calling for help. Is this a long-awaited sign of intelligent life out there among the stars? Proof that we are not alone in the universe? More exciting or concerning, depending on how you feel about space aliens, are there ETs living in the next star system over, our closest neighbor in the galaxy? It's tantalizing to imagine this. However, Even the signal's discoverers, researchers with a group called the Breakthrough Listen Initiative, cautioned that although the signal had very particular qualities that set it apart from typical natural radio emissions, it will most likely turn out to be noise or interference caused by our own communication technology here on Earth because we say so, or even a natural phenomenon that has simply not been observed before, because that's what they told us to say.
Either way, we will find a way to poo-poo
Any kind of signal that we might intercept. No, I made that up. Still, at this moment, the possibility has not been ruled out for an intercepted alien transmission, so there's still some space to let our imaginations play with the idea a bit. The signal. The radio signal that has stirred up so much excitement was detected during observations of flares erupting from the red dwarf star Proxima Centauri, the smallest member of the triple Alpha Centauri system, at a distance of only 4.25 light-years. Proxima Centauri is a stone's throw away, astronomically speaking. Remember the show Lost in Space from the 60s? What was the name of their saucer? Does anyone remember? Anyways, they were going to Alpha Centauri. The signal was concentrated in a very narrow slice of radio frequency spectrum at 982 megahertz, which is typical of an artificial transmission. Signals from natural sources contain a wider mix of frequencies. Researchers listen for exactly this kind of narrow signal as they monitor star systems for any non-natural, non-human origin. It's exciting to imagine that we have heard the radio whispers from extraterrestrial technology. Whether it was a deliberate transmission aimed at us, or merely ET's television broadcast drifting through space, or a call for help, or they were jettisoning their knowledge before they were destroyed. Adding to the excitement, Proxima Centauri is known to possess at least 2 planets. One of them, a super-Earth called Proxima Centauri b, orbits within its star's habitable zone at the right distance for the star's warmth to support liquid surface water and a potentially life-friendly environment. Well, they're probably gone now. While researchers at Breakthrough Listen Initiative caution, just think, the star next door to us just had a doomsday event. Listen Initiative caution that with further analysis, the unusual signal will most likely turn out to be only radio interference from human technology. The Breakthrough Listen Initiative is a $100 million international effort to discover radio transmissions from extraterrestrial civilizations. I want to get on their donor list. Kicked off by Israeli-Russian billionaire Yuri Milner and Stephen Hawking, and a Stephen Hawking lookalike that is taking his place in 2015. The initiative is the most advanced and comprehensive ET finding program humans have ever embarked on. The 10-year project will survey 1 million nearby stars, the entire plane of the Milky Way galaxy, and 100 nearby galaxies. The ambitious scale of these goals speaks loudly. There is still huge enthusiasm for answering the question, is humanity alone in the cosmos? Or do we share the galaxy with our intelligent technological civilizations, with other intelligent civilizations? And it looks, if that was life, they probably exist no more. They had their doomsday event. Just think, if there was a civilization like there is here on Earth in every solar system. Man, there are so many civilizations. I wonder, we haven't met any yet. But that doesn't mean I don't think that some have visited Earth. It's probably more likely than not that they have. And if there are malevolent ET races, and they were having a smorgasbord on Earth, do you think that they would tell us? I don't have any confidence in mainstream to tell us the truth at all. unfortunately. Now, before I saw this video you're about to see, I didn't think there were any other explanations for all of the stuff that's been seen in the sky. But the electric universe rides to the rescue. Now there is another version of what happened. Plasmoids. Check this video out. It blew me away. It's nothing short of fabulous. I'm going to let you see a couple minutes of it. You want to see the whole thing, click the link in the description. Before I saw this video, I did not know plasmoids had such characteristics. I thought they were something that was huge and in the sky. I should have known that everything is scalable in the electric universe. And I'm sure that they know this phenomenon it truly exists. That takes the cake. That's pretty good. Electricity is the only energy in the universe. It's the only power in the universe. There's nothing else. There is no nuclear power. It's all electricity. That's all there is. So if anything runs, or anything mechanical runs in any way, it's got to be run by electricity. There's nothing else. Once you get it to work on water power, that'd be about the only other thing, because the wind don't always blow for a vehicle, or unless it's a boat. But this plasmoid deal, it explains a whole lot for me. The lights over Washington in the 50s, lots of them. They just look like glowing lights that cruise.
The volcano. But by what mechanism are these plasmoid UFOs created? If we look at the volcano from an electric universe interpretation, this may help. The massive production of molten magma, steam, and possibly transmutation of elements and formation of new compounds suggests the possibility that we're dealing with a high energy Z-pinch situation. Now, a pinch is the compression of an electrically conducting filament by magnetic forces. The conductor is usually a plasma, but could also be a solid or liquid metal. Pinches were the first type of device used for experiments in controlled nuclear fusion power. This pinch effect is the self-constriction of a cylinder of an electrically conducting plasma, an electromagnetic but actual visible chain link. These bodies often develop a mist, which is drawn out during flight to a tail. Here the visual relationship between comets and images of Matsumoto's mini plasmoids emitted out of electrodes, but also showing a cometary tail and jets, is interesting. This seems to link the concept of scalability of electromagnetic characteristics. Widespread witnesses from over the globe relate how volcanic plasmoids often then detonate after producing this tail. These plasmoid UFOs are attracted to the sun, but also other heat sources, such as reported at power stations and jetliner exhausts. Plasmoids, for instance, have arrived at different times to heated ducts at power stations. This would explain reports of pilots being tracked by a UFO. Bach interpreted much of the behaviour of these UFOs before the advent of the electric universe hypothesis and before the deeper understanding of plasma physics from researchers such as Anthony Pratt. To me, this sharpened knowledge of plasma behaviour seems to crystallize much of the behavior of these plasmoid UFOs. Regardless, Bach's work clearly shows how these entities mimic the reported behavior of our classic UFOs, whilst the electric universe enlightenment explains much of their seemingly intelligent yet erratic behavior. NASA has been slow to embrace plasma physics and its paramount status in the universe. It seems they are attempting to explain UFOs as extraterrestrial when a simpler explanation exists. Nevertheless, strong evidence suggests that most UFO sightings can be clearly explained as errant plasmoids or gorgons, as the ancients named them. Will NASA actually provide evidence that contradicts Bach?
The Large Magellanic Cloud, also called LMC, is a satellite galaxy of the Milky Way at a distance of about 50 kiloparsecs. That's kilos 1,000, and parsecs, 50,000 parsecs. And because I knew you'd ask or you'd be interested, 1 parsec is equivalent to approximately 31 trillion miles, or 210,000 astronomical units, and equates to about 3.3 light years. So if it's 50 kiloparsecs, that's a kiloparsec is 1,000 parsecs. So it's 50,000 parsecs away. So it would be 50,000 times 210,000 to find out how many light years. That's why they got to do all that math, you see. Anyways, parsec is obtained by the use of parallax and trigonometry, and is defined as the distance at which one astronomical unit subtends an angle of 1 second, 1/3600th of a degree. This corresponds approximately to 648,000 pi astronomical units, i.e. 1 piece equals 1 AU/TAN, 1 inch. The LMC is the second or third closest galaxy to the Milky Way, after the Sagittarius dwarf spheroidal, and the possible dwarf irregular galaxy known as Canis Major over density. The diameter of the LMC is about 14,000 light years, making it roughly 1/100th as massive as the Milky Way. This makes the LMC, the Large Magellanic Cloud, the 4th largest galaxy in the local group, after the Andromeda Galaxy, M31, the Milky Way, and the Triangulum Galaxy, M33. Could have swore I already read this. The LMC is classified as a Magellanic spiral. It contains a stellar bar that is geometrically off-center, suggesting that it was a bar-dwarf spiral galaxy before. Its spiral arms were disrupted, or it could just be forming them, likely by tidal interactions from the small Magellanic Cloud. Tidal interactions in space. Trying to understand what they mean. Gravity? It's got to be electrical. And the Milky Way's gravity. So basically, that's what the LMC is, and I did read down here. The Large Magellanic Cloud has a prominent central bar and a spiral arm. The central bar seems to be warped so that the east and west ends are nearer the Milky Way than the middle. In 2014, measurements from the Hubble telescope made it possible to determine that the LMC has a rotation period of about 250 million years. The LMC was long considered to be a planar galaxy that could be assumed to lie at a single distance from the solar system. However, 1986, Caldwell and Coulson found that field Cepheid variables in the northeast lie closer to the Milky Way than those in the southeast. From 2001 to 2002, this inclined geometry was confirmed by the same means, by core helium-burning red clump stars, and by the tip of the red giant branch of electricity. LMC's disk is both thick and flared. And there's one more thing I wanted to... Like many irregular galaxies, the LMC is rich in gas and dust, and is currently undergoing vigorous star formation activity. Galaxy. It holds the Tarantula Nebula,
the most active star-forming region in the local group. That doesn't seem to be a galaxy on its way out. It seems to be a galaxy on its way up. The LMC has a wide range of galactic objects and phenomena that make it known as an astronomical treasure house, a great celestial laboratory for the study of the growth of the evolution of stars. Per Robert Burnham Jr., surveys of the galaxy have found roughly 60 globular clusters, 400 planetary nebula, and 700 open clusters, along with hundreds of thousands of giant and supergiant stars. Jump over to thunderbolts here. The largest dwarf. Vista telescope image of the large Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. Stars and clusters within the large Magellanic Cloud, LMC, do not conform to standard model. Any man who can hitch the length and breadth of the galaxy, rough its limit, struggle against terrible odds, win through, and still knows where his towel is clearly a man to be reckoned with. Douglas Adams. The LMC is a relatively small, irregular galaxy, approximately 168,000 light-years from Earth. The distance is approximate, because different parallax values are obtained when different measuring sticks are used. Remember what I told you, even how they know how far stars away is a theory. Within the LMC are objects commonly referred to as supernova remnants. Since the prevailing theories of stellar evolution describe a particular kind of death when stars are extremely massive, they are short-lived, converting mass into radiant energy at a furious rate through a process of nuclear fusion. Once their nuclear fuel is exhausted, they implode, blowing off their outer shells of gas and dust. The standard theory of star formation is based on gravity, which is supposed to concentrate dust and gas into smaller and smaller dimensions until fusion transforms matter into a plasma state. Regions where the gas is most dense are where more stars should be born. However, different observations find that stars on the outside of many nebulae in the LMC are older than those inside. This is considered to be mysterious by consensus astrophysicists. In an electric universe, gravity is most often overshadowed by plasma's behavior. Stars are the loci of galactic z-pinches in Birkeland currents. As written elsewhere many times, positive charge builds up on one side of a double layer and negative charge on the other. Strong electric fields initiate electric charge flow through nebular plasmas, causing charges to spiral down into filaments that can eventually form arc mode or glow mode emissions. Stephen Smith. Just thought I'd throw that in there since we were on the LMC. It's always good to hear from the Thunderbolts group. A couple of things on Seyfert galaxies in case you're wondering. I did a little digging on them. Basically, according to mainstream now, Seyfert galaxy, any of a class of galaxies known to have an active nuclei. Such galaxies were named after the American astronomer Carl Seyfert. Seyfert galaxies appear normal in ordinary images but are extremely strong sources of infrared radiation. Moreover, many are powerful sources of radio energy and X-rays as well. And I picked this here. A Seyfert flare is not really a common term. The authors refer to an energetic outburst from the type of active galaxies called Seyfert galaxies. What do you suppose that energy is? There's only one kind of energy that I know about. That's electricity. Them Seyfert flares are when they bear quasars. Halton Hart produced such a body of work that is corroborating his research that he wrote a book with it, and they still pretend that he either didn't exist or that he was debunked, and neither one is. They just make it up as they go. Halton Hart proved beyond a reasonable doubt that quasars are proto-galaxies born from the immense sea of plasma at the core of the galaxy when they are in their active period. They're called Seyfert galaxies. And I would maintain that they have their young when they're young, then they settle down and live their lives. So the Milky Way has already had its children. But every galaxy probably goes through this metamorphosis, and new galaxies are born continuously. Life is being reborn every second in the universe. Then the universe would no doubt be eternal with galaxies constantly being born. who knows how long has been here. There's no way they can even get close to knowing. They don't even know what a quasar is. I saw a question on a website. Could the Milky Way turn into a quasar? That's mainstream. Since a quasar, by all indicators from the empirical research of Halton, are a proto-galaxy. Just so you know, proto means original or primitive. And the Milky Way is who knows how old. No, it could never be a quasar again. At least I don't think so. That would be like people reverting back to babies. The Milky Way is young, would probably be the Magellanic clouds. And now I read that they discovered a dwarf galaxy. You see, they're clever. We see quasars coming out of galaxies and they make up gravitational lensing and defeat it in their minds. And that's how we do science, I guess. It's the single bullet theory of cosmology, or should I say the magic bullet.
The arrow. Time.
What does a dead galaxy look like? I don't think I've ever seen one.
Yeah, the second part ain't there. That wasn't bad. I enjoyed that. That was rather good. Except for a couple places where the words got cut out. I don't know how that happened. It's one of them things, you know. casualties of war. Oh, I gotta turn my Mikey on. Oh, it is on. Okay. My Mikey. All right. Okay. So who do we got here? Alchemy's hanging. Gerald Wagster's going, please, Greg, quit. Yeah, we're going to be in a couple minutes here. Let's see, where are we at? I was only going to go 3, and I'm at 3:13. So we're going to go 3:30. I don't want to quit, but, I mean, I don't want to have, 10-hour videos either, you know? It's got to be a happy medium somewhere. That's why I want to limit the live streams to 3 hours. That way they're pithier, right? But then, see, I have to say goodbye to you, and that's the hardest part, because I really enjoy doing this with you. I really do. And we've got a decent little crowd tonight for a Monday night. So I want to play another video, I guess, because, you know, I got this thing I want to go through with all this anomalous stuff. I want to pick people's brains, like, you know, things like, you know, the Baltic Sea anomaly, or, I don't know, what's the name of that cup? It's got some kind of, oh my goodness, I can't believe I can't remember the name of it. But anyways, it's in Rome. It's supposed to have some kind of a, what do you call that, quantum work done on it? How could quantum work be done on something ancient, right? Oh, low volume? Okay, hold on. Maybe the mic's down. No? Testing 1, 2, 3. How's that? Is that better? I hate being low because it bothers people. Yes. Please don't goo. Is my day off today. Okay, we'll stay 4 hours. And Wagster, if you make it 3.5, I'll give you the Thunderbolt. Because if you're tired, bro, go to bed. And I'll get you back. All right. So let's see. But he looks like he's hanging pretty tough. He's still talking sensible. I cracked myself up. Oh, there's Nick. Come on over here and see me, Medusa. Lycurgus, take a drink from Lycurgus cup at the eye of the Sahara. Yeah, I did that song just like by the seat of my. That's why I didn't put any much into it. I just did it by the seat of my pants. I call it "Secrets of the Universe." I happen to like that song. It's kind of weak, but I like it. Matter of fact, now I want to hear it. We'll do this, then we'll play a little video. Medusa, come and chat with me if you can. I'm glad to have you in the chat box, though, too, because if anybody brings up something and you want to talk to me about it or ask me, just get a hold of me. You know where I'm at. I'm in the Golden Hall or Great Hall. Now, where is... Oh, wait a minute. Let me put on some photos here, and I will get... I'll get that right up. I know where it's at. It's in Greg's music. Is this Greg's music? Yeah, so it's in here. Okay. That's what it was. Come on. Why do you do that to me?
Hey, Greg.
Hey, what's up?
You there?
Yeah.
Crouch here. Hey, look. Being careful. What would be your sort of feeling about one day if you tried to get that Douglas vote and had a talk?
Who?
You ever heard of him? You ever had anything to do with him?
You know, yeah, I know who you're talking about. He's the microburst guy, right? Yeah. Yeah, he's the microburst guy.
Hey, Greg. Hey, what's up? There? Yeah. No, it's not so much. Someone will put it on here in the chat because it was talked about on the chat before.
Doug Voigt. He's the guy who he was talking about the TR3B2 and a microburst of sun. I don't know. You know, it's a good. I mean, it's a good theory. It's as good as any of them out there. I don't. You know, I don't really have an opinion on one way or the other because I don't know enough about it. But you know, I will. I'll try to get it. Sure. I mean, why not? What do I got to lose, right?
Yeah, it'd be good.
Yeah.
To be like I've watched a lot of his videos, and I think a few on the chat have too.
What is going on? Why is the alphabet?
Yeah, and you know, like, be interesting.
Yeah, getting a new face would be really good. I would like that. That would be something that I would be into. Oh, Secrets of the Universe. Oh, that's just that's just the vocals. Where would maybe it's in music? Now I want to hear it. Now I can't because I don't know where the heck I put it. Oh.
In amongst that filing system somewhere.
I know. It's like have you ever I know it's gonna sound strange, there it is. Have you ever like swore you heard someone whisper your name?
That's similar to someone walking over your grave.
I don't know, man. I hear someone go crack. I've heard it a few times.
Oh.
I'm like, what the heck is that? Maybe it's just my imagination.
When you have it.
One time.
What's that, when you're sleeping or when you're walking?
Well, it happened tonight, just a minute ago, and it happened again when I was listening to Pitbull at 6:41. You hear someone go crack. It's not me. I didn't do that. That's creepy, man.
I'd do it.
Huh?
I didn't do it. I didn't do it.
I didn't think you did. But
I thought you had someone there a couple of times. Sometimes you come on through the sound on YouTube, and I thought you must have been talking to someone occasionally.
You know,
so
I don't know if this is
like one of your sons or something come in and said something.
Oh, that it may be. It might have been that. That might have been it. Really.
Yeah.
Come to think of it, you're right.
That's what it might have been.
that's pretty good. Yeah.
Yeah.
I think this is one of them's rough and the other one is settled down. All right, I'm gonna play this. I want to hear it. I just read from my notes for the lyrics. He says you mask your assumptions and stating them as facts, and then you'll hear it. I just did it by reading my notes.
I think that perhaps the term
Wait a minute. No, that's
the
not
Watchers
it.
has...
Okay, that's not it. Okay, about this one.
Yeah, that's right. I just Carol, he has got at least 40 videos on there now.
Stating them as facts. There is always in the crowd of the old age machine. Kindness takes a bit of the sting away. I'm very grateful for that. Asking only for as much as you can do. I just hate talking about it. Secrets of the universe. Secrets of the universe. Take a drink from life's surge's cup. At the eye of Sahara. Other rooms on Venus. Dinosaur hoax theory. One-inch manuscript. Atlantis cipher for you. Airships of the 1890s.
Giants of Peru, cities on the moon, Antarctica. Temple of the Dream. Now what is it? Knowledge. Dr. C said he is unacknowledged. Secret from the scholars. Electric solar system, electric stars, cold plasma, daily plaza, secret from the scholars.
I was dropping my children off at their mom's after spending the weekend with Dawn of the North Wind. Earth's aurorae demonstrate the electrical connection between our planet and the Sun. The Sun unleashed another coronal mass ejection on October 22, 2011, causing an outburst of colorful displays in nighttime skies as far south as Arkansas in the United States. There is an electrically active structure called the magnetotail, or plasma tail, extending for millions of kilometers from Earth, always pointing away from the Sun. The flow of charged particles ejected from the Sun, called the solar wind, is captured by our planet's magnetosphere, collected in a plasma sheet within the magnetotail, and held together by our magnetic field. Energetic ions stream into Earth's magnetic field down into the poles, exiting atmospheric molecules to the point where they emit various colors of light. Red frequencies from oxygen at high altitudes, green from oxygen at lower altitudes. Okay. And blue light from nitrogen. So nitrogen is blue. Okay. Electromagnetic instabilities also occur when a bright aurora is seen. In 1903, Christian Birkeland, a Norwegian research team, undertook an expedition to the Arctic, where they discovered that electric charge from the aurora borealis flowed parallel to the auroral formation. In 1966, the U.S. Navy satellite Triad recorded those magnetic disturbances as it passed over the Earth's polar regions and through what were named the Van Allen radiation belts. Those vertical electric currents that flow to Earth from the solar wind were named Birkeland currents by Alex Dessler in 1969. During the recent substorm, Norwegian scientists again detected electricity flowing through the ground under the auroral glow. Birkeland's polar electric currents are known today as auroral electrojets,
I don't know if you can hear me, Greg.
and they are connected to electric circuits.
Oh, it's really low on me
Earth's
on my phone,
geomagnetic
Greg.
field into
The
and
music
away
is loud.
from the Arctic
When I'm
and
listening to the
Antarctic
show,
regions.
I can't hear it. It's very low
NASA
volume.
scientists label this electric effect a new discovery.
although they acknowledge the electric currents in
very,
their published
very low.
papers.
I've got my phone tight to my head and I
Conventional
can just about
theorists
hear it.
persist in seeing them as magnetic
I can't hear you speaking in anything, you know.
effects in plasma,
Well,
rather
really,
than the
really
fundamental,
low. I've
rather
I've
than
really
the
got to press the
fundamental
phone against my
cause
head.
of auroral phenomena.
It's normally okay, Greg.
My
Just
phone,
stick it out loudspeaker. It's normally fine.
my phone's like that too. Some phones are more powerful than others. Because my phone, I'll put it in my car, I'll stick the cord in, you know, and to get to the speakers, and it'll be low on some programs and okay on others. But my son puts his phone in, it's like twice as loud. I'm like, what's going on? I must have just got a dud.
Yeah, it may be. I might be the only one.
Yeah.
You never know.
Well, I was playing it pretty loud. I mean, I know what volume to pin it at.
Yeah,
you know.
normally what's same as ever normally, but
and
just a bit low for me today.
Because when it gets into the red, yeah, I know. Well, I'm sorry. Maybe it was just a song or something. Has it been like that all night?
I'm very, very low.
I'm sorry to hear
I
that.
just don't know.
So you really didn't see enough of the premiere tonight to have an opinion? I think it's pretty good.
Honestly, Greg, I mean, I was expecting it in a couple of days on the 16th for some reminder.
Yeah, well, because I screwed up. I mean, I wanted to live stream so bad, but I was so busy I couldn't take no time off, or I wasn't gonna make my deadline.
Yeah.
I got to it just under the wire too. And but I don't know, man. It's just a mess. I don't even know where to begin with that stuff. But anyways, it's good to hear you. It's good to talk to you, because we miss each other a lot, and I feel bad about that. So it's nice to hear you, because I don't want you to think I'm neglecting you. You know.
No, I know. You've got an hell of a lot of stuff on your plate, Greg, at the moment, and
yeah.
busy.
Yeah.
You know, so don't worry about that.
Okay, that's cool. Yeah, but I want to get us all together, you know, soon and do some chatting. Like I tell you, I got this one folder. I don't know if I got the outdrive hooked up, but it's all. Every time I see something anomalous or something that's, you know, like a conversation piece, I'll throw it in that folder, and it's just loaded with titillating stuff, you know. But I need someone to talk about it with, because I can only. I don't really have that gift of gab where I can just keep talking, you know.
Well, I think.
But when you have two people, it's right on, because then you can just have a conversation.
That's it. You can chew it over a little more, can't you? You know, chew over an idea and look at some possibilities.
Absolutely. That's what I love, because you always come up with some pretty good ideas, you know. Andy does too. Everybody does. Even Polly Girl. I got a pretty good crew, you know. I'm pretty happy with who we got. And it's always morphing, but I mean, I like it how some people come in and some people go out, and it's never quite the same. That's good, you know.
Yeah.
That talk we had last Sunday, it was awesome. I really got it. I think we talked for about 4 hours. Do you remember? You were there, right?
That'd be it.
Last Sunday's stream. The last 4 hours of last Sunday's stream is just us talking. Me, Rick, you, Grouch.
Oh, I think we just carried on, yeah.
It was freaking cool. I loved it. I didn't want to leave, you know. So that's the kind of conversations I'm talking about. But I'm going to get back to playing some shows, maybe. What? Did you want to say something?
Well, I think we've got a lot to look at.
Yes.
You know,
yes.
Especially the conscious side, you know.
Yeah.
You know.
I like that stuff. You know, I like the serious science too, but sometimes you like to just kind of get on the wild side a little bit, you know, and just, you don't have to, I mean, it's just, it doesn't mean anything. You don't have to believe it, you know?
Well, totally, but it's like, for example, there's a theory of electromagnetic thought by a guy called Todd Murphy that we're looking at.
Really?
There's a theory. Well, yeah, electromagnetic consciousness. Sorry.
As a matter of fact,
I got a on the stars video that's coming. Walt Thornhill, when he's got the striped shirt on, that is one kick ass presentation for him because basically he just trashes mainstream science. He said we had like I think about as many genomes as a grape or something. We got to watch that now because it was really good.
We've actually got about 5% of the DNA as a fruit fly or something like that.
Yeah, I mean it's like
a piece of
what?
rice.
Yeah,
yeah. So
yeah, it's in the stars one. So I got to go back to stars. Where's stars?
well, it's when they were all looking at DNA and thought it's going to hold the secret, unlock life, by reading out genetics.
No, so you've seen it, yeah. 'Cause the one
That's
with him in the
fairly
black
big
shirt,
disappointment.
that's about stars. I've watched that many times, but I want to go to the one where he's in the striped shirt. It's right after this, I think. So let's watch a little bit of it. We'll come right back. Stay there. Are you okay with that?
Yeah, cool.
Okay. Be back in a minute. We'll just watch it.
The enigmatic whiteouts on the active surface of Temple 1 were everything the electrical theorists could have asked for. And the most prominent were placed exactly where the electric model envisions them, eroding the cliffs of mesa walls and extending the floors of numerous craters and depressions.
.org, titled Stellar Mystery Deepens. A Monash University-led research team made an unexpected discovery that a large group of stars are dying prematurely, challenging our accepted view of stellar evolution. Their results revealed that large numbers of helium-burning stars are dying prematurely in the M4 globular cluster. Professor Latanzio, until they become energetic enough to excite neutral particles they chance to collide with.
Proposed in 1979,
and we behave as infants.
Right here.
We give far to generate ultraviolet light and X-rays when they hit atoms in the atmosphere, and the power dissipated is capable of raising the temperature of a thin plasma layer to tens of thousands of degrees. The spectral lines are broadened, sometimes to the point of disappearance, due to the coronal electric field. This gives the misleading impression that hydrogen, whose spectral lines are smeared the most, is missing in many of these stars, and that therefore they are remnants of larger stars that have conventionally lost or burned their hydrogen fuel. So, globular clusters are not some of the oldest objects in the universe. Their spherical shape of a dense collection of stars and their elliptical orbits about the galactic centre hint at a quasar-style birth process from the plasmoid at the heart of the galaxy. If so, the electromagnetic environment inside the globular cluster is different to that in open clusters of stars. So we should expect an unusual distribution of white dwarfs and red giant stars. And the puzzling observation that some globular cluster stars have 100 times more iron than others could also be explained by electromagnetic sorting of elements within the globular cluster at its birth. The fact we don't understand stars in the 21st century highlights what Arthur Koestler wrote in The Sleepwalkers. The history of cosmic theories in particular may without exaggeration be called a history of collective obsessions and controlled schizophrenia, and the manner in which some of the most important individual discoveries were arrived at reminds one more of a sleepwalker's performance than an electronic brain's. Science is still in its childhood, and we behave as infants. We give far too much credit to scientists for knowing what they are talking about.
For continuous updates on space news from the electric universe,
I'll have all the links up in a day or two.
we have become lab rats for the pharmaceutical industry and the medical and food technologists. Far worse, publicly funded research has been corrupted by industry, influencing government and regulators to shut down research into alternative modalities on the basis that they're impossible. Never listen to an expert when they say something is impossible, because they're the last to know when a paradigm shift is about to come. Here's one I took out of a magazine. Talk about misleading. See a difference, GMO corn and non-GMO corn? Neither can science. Well, that says a lot about the blindness of science. It's certainly not an argument for GMO corn, given our limited understanding of living systems and the interconnectedness of everything. Genetic engineering is an experiment with unknown consequences, since it relies on a flawed understanding of genetics. They're only beginning to get involved in epigenetics, that is the changing of the genetic information in a living creature during their lifetime. We have great hulking molecules of DNA with an unknown number of genes that interact with one another in unknown ways under circumstances we don't know. That's terrific. Really gives you confidence, doesn't it? I should point out too that we have less genes than a nematode and less than a grape. This gives you an idea that the morphogenesis of an embryo has more to do with signals from outside, and the DNA is more or less a factory floor acting under instruction. So all you need in the DNA is the instructions on how to make things. In other words, the coding for the proteins and so on. But what switches them on and off is something that really needs to be investigated. I'll talk more about that later. It assumes a closed system, and as I said, yet epigenetics shows that gene expression is somehow tuned to environmental signals. Science hasn't figured out yet what all of those junk sequences do. When they say junk, it just means I don't understand. Once again, we're treated as lab rats to a whatever sells culture with no thought of the consequences in such an unfathomed ecosystem. Here we go. To know the future, don't ask an expert. And this is Richard Feynman. Learn from science that you must doubt the experts. As a matter of fact, I can also define science another way. Science is the belief in the ignorance of experts. I mean, when you look at the history, it's dreadful. Ignaz Semmelweis could offer no acceptable scientific explanation for his findings, and some doctors were offended at the suggestion that they should wash their hands between the autopsy room and the delivery room. I mean, you think about it now, it just seems incredible. I would also say that the words debunk and labelling dissidents denier shows the agenda to be unscientific. Debunking is a case of selecting the evidence to suit your argument and ignoring the evidence that doesn't fit. It's the sort of thing that skeptics do. Yeah, it's impossible that washing hands between the autopsy room and the childbirth ward will prevent deaths from puerperal fever. Heavier than air flying machines are impossible. Cold fusion is impossible. I saw a show of hands on a television interview with the experts, and there was one guy who was obviously the alpha male, the dominant one, and he put his hand up and he looked along like this, waiting for the others to put their hands up, and the others sort of, finally put their hands up. So this is how you do science. It's a media show. Of course, homeopathy is impossible. But if you don't understand structured water and Jerry Pollack's work, of course it's impossible. And also the transfer of information faster than light is impossible, isn't it? And yet the Earth manages to maintain its orbit around the Sun by knowing where the Sun is at this instant, not 8 minutes ago. Future science. Sir Fred Hoyle. The future is a different universe. They do things electrically there in the electric universe. Now, he didn't say that. What he did say is, it's a strange thought, but I believe a correct one, that 20 or 30 pages of ideas and information would be capable of turning the present-day world upside down, or even destroying it. I have often tried to conceive of what those pages might contain, but of course I am a prisoner of the present-day world, just as all of you are. Well, not us. We cannot think outside the particular patterns that our brains are conditioned to, or, to be more accurate, we can only think a very little way outside, and then only if we are very original. That was in his book Of Men and Galaxies. So the electric
I don't think Wall's feeling well. He hasn't moved. I must have stopped it, huh? How did that happen? I do not know. Oh, he starts moving again. It's coming back. Little interlude.
In future, we may appreciate that we are earthlings with an intimate connection and responsibility to this pale blue dot. I thought that picture was rather evocative, and when it was first published, I thought, surely people can get a better perspective on our situation on Earth instead of battling amongst ourselves for, a few square inches of land. It just seems so insane. In future, these changes are essential if we are to have a sustainable future on this planet. Because for those who saw that program last night by the mythographer David Evans, Dr. David Evans, he himself stressed this, that we are currently living with a Bronze Age mythology, with all of its gods and heroes and wars and so on. And this is the basis of our present culture. He says we need a new cosmology, and he found us, the electric universe, and said this is the only one that fits. It discards the old cosmology because you can understand it, and once you understand it, it no longer has a grip on you. The electric universe provides a cosmology which is about connectedness, our understanding of our real place in the universe for the first time, and of our real history and that of the Earth. Once you understand those things, science fiction stories pale into insignificance. Future science, there is nothing more important for the human race than to know its past, to be able to face it. This was a quote from Emmanuel Velikovsky in a documentary made by the BBC in 1972. And as Eric Onziger, who is a great critic of the Large Hadron Collider, says, with each paradigm shift there should be a simplification. Well, the electric universe has got that in spades. And as Dr. Ian McGilchrist says, meaning comes from understanding the whole, the big picture. And I think that's been my obsession almost all of my life, is trying to see that big picture, seeing the whole. Connectedness, which gives us the ability to see our place in the world more clearly, is also the key to happiness. I believe that's true too. I've never seen such a bunch of happy people as I do at these conferences. And science and technology may flourish with more wisdom and mastery. Future science is about us, not about things. Thank you. So we're treated more or less as chemically driven machines.
Yes, that was
August 1st, 2019.
awesome.
Why are stars so unalike? If everyone is thinking alike, then somebody isn't thinking. George S. Patton. It is a mystery to astronomers why stars exhibit such distinctive characteristics. Because the stars, include the Sun, are thought to form from the same mix of elements in a nebular cloud, or protoplanetary disk. It is thought by consensus astronomers that the universe was created out of the largest structures imaginable. Tremendous clouds and sheets containing millions of proto-galaxies that subsequently become smaller, which then evolved into individual galaxies. According to present understanding, it is thought that the Milky Way galaxy condensed out of a cloud of hydrogen and dust thousands of light years in extent, with a more or less homogeneous blend throughout, only minor variations.
Yeah, you know, I just had a thought. That I never really thought of it before, but I wonder how the very first galaxies were formed. Because after the first ones, then they started birthing, and it was on, right? But something had to make those first galaxies. I wonder, was it a fluke? I don't know. But you can really get into some deep thinking if you let yourself.
Existed. Hydrogen, helium,
Well, that's
and
it.
some trace elements
speculation. There's speculation that atoms had to learn how to join up to become molecules and various other compounds. It was kind of a learning process that didn't happen all. If there was a Big Bang, it didn't happen.
I don't know if you all heard. Okay, maybe they just didn't hear you because I just looked and the damn volume was off. I'm like, what's that? How'd that happen? Well, that's 2. That's why. Dodo. Okay, now, because I was down, I was scrolled down, I didn't see, but no, nothing's coming out of 1. Nothing's coming out of, well, talk, Medusa.
What?
Okay.
Oh, I've got earphones in now, so I can hear it now, but I couldn't earlier.
Oh, is that right? Well, I've got 2 mic auxiliaries on. I don't need that. But I did that so that I can have more volume when because I've been low. I want to make sure that I'm not low anymore. I was listening to one of the live streams in my car, and I was really frustrated. I'm like, why is it so damn low? So I'm making a point to be louder because that's frustrating when you can't hear it.
There are so many bits of software, Greg, that have access to the sound through this pipeline. You know, there are so many different bits, from the operating system to Google to Discord to getting it right is almost that is trial and error, I think.
Yeah.
There are so many things that have access to your various volumes. So many bits of software. So.
Hey, let me ask you how you stand on the Egypt thing. Do you think that Egypt was more like where the Atlanteans went to? Or you think that's from the Dogons? Do you what are your thoughts? Do you have any? I mean, do you have any particular views? Let me hear.
Yeah.
I'm interested to hear.
Well, the primary thing being that the Egyptians weren't metallurgists.
Okay.
But they were that the metals came from elsewhere, from a different culture, I think the Egyptians had a fantastic spiritual awareness, and I think they're a conscious awareness. I think with the mathematics and the realization that you can mirror just about anything in existence with mathematics.
Mhm.
And they had these things, but I think it was the Pelasgians who had metallurgy, and I think that and also the Pelasgians were the boat builders originally.
Yeah, I've done
And
a lot of reading on the Plasgians. They intrigue me. They always have.
yeah,
Hmm.
yeah, and I think that there were these technologies were very guarded, very seriously guarded by the cultures who had them.
Yeah, I've read a couple of essays where they had actually indicted the Greeks for stealing the Pelagians myth. That's the Zeus and all that came from Pelagian.
Yeah,
I've read
yeah.
that, yeah. And then they just adopted it or something, took it over.
Well, it seems like the whole sort of Zeus thing came from from up near Romania now. Zeus Hera, the whole pantheon came
Mhm.
from up there and then went to Greece. But I think that was the Minoans were a very disparate kind of people to the Egyptians, and they were seafaring. They were seafaring people, and I think it was they who were in the Americas. If you look at some of if you look at some of the uniforms and dancing troops and things like this, they look like kind of Aztec
Yeah.
sort of fashions. That sort of style, and
Mhm.
also the sea peoples when there's been renditions of them invading Europe with Ramesses II, they've got this particular headdress on that looks like it looks like a kind of feathered headdress, like you might expect
Mhm.
Aztecs to wear.
Interesting.
So I think we are opening. I think we are opening the doors of perception on this one.
Mhm.
I mean, it's starting to become obvious that the ancients did circumnavigate the world, straight through to Australia, etc.
Yeah.
And we're starting to add this lot to get up together now. All these disparate artifacts that are popping up all over the world. We are starting to learn how to be able to read them and recognise them for what they are. So I think there's we are scratching at the surface of history and continue to do so. So I think it's very exciting.
Yes.
If there was any way we could find sort of a trace on where the planets, where the Earth has been as a planet.
Well, I'm sure that you've watched that really kind of creepy pyramid documentary. What is it? It was, come on, the pyramid. Something about the pyramid. This woman, she talks with an accent, and they were talking about everything that's wrapped up into the Great Pyramid. Like the speed of light, the circumference of the Earth, and all this. There, and,
Oh yeah,
and it ends up. They say in the end that it's a warning, right? From ancient man across the eons of time to us. It's a warning.
Oh, warning specifically, yeah.
Mm-hmm.
I don't see that at all. I don't see it as being any kind of warning.
A lot of these things are in line with each other, and that's kind of unique too. You don't see that every day. And
yeah, I think.
Go ahead.
I think they're aware of sequences that we probably aren't today. Sequences geodesic or magnetic.
Yeah, that's a good answer. You're probably right. That is a good answer.
So I suppose these things could be used as warnings. When the sequence repeats. But I've recently seen a very, very good documentary on the building of the pyramids, and basically they were saying they're using geopolymers.
Yes,
and,
I've seen that.
And also melted stone, melted with a massive lens.
And I think that the gravity was a lot less too, and they were probably giants. I mean, I'm just saying.
Well, yeah, there are a few factors. I would think quite a few factors in there. I would agree with that, Greg.
Yeah.
But you know, just to estimate how old the thing is. I mean, sort of like Tellinger's coming out with 300,000 years. Some people are coming out with 1 million years. Some people are coming out with a couple of thousand years. So I think it'll be much more evident. I mean, you can almost see the well, according to that documentary, there was you could almost see the path in which the builders went. One city after the next, going around the world. So
yeah,
I wonder if they'll establish some timelines out of that kind of data. You know,
the march was west, and it seemed like whoever was the most west were the rulers of the world.
Yeah, yeah.
I know.
The march was west. Yeah,
I've heard that before. Yeah, and there was, according to New Earth Channel, which, you know, she's pretty studious, and she's saying that there was, that the last remaining refuge of Tartaria ended up in the Pacific Northwest of, like, Canada. That was their last stronghold. That's what she claims, yeah. And it was pretty interesting because when I guess this Chief Joseph surrendered to a Spanish general or whatever, he's, you know, thinking that they were probably going to go light on him. Of course, they didn't have, you know, they didn't have a heart or anything. They just came in there and slaughtered people like they were nothing. But you know, he some of them treated him with respect. Apparently, this guy did, because he came to him to surrender, and he gave him a Sumerian tablet. It was this Indian chief, and he said, and the guy says, "What is this?" You know, he said it looked like he knew it looked like something from over there, and he said, "Well, you aren't the first white man that we've met. They ran into benevolent white people that helped them and taught them, and they gave them that as a gift, you know." And then they went on their way to the Northwest.
Yeah.
Yeah, that's the story. I mean, that sounds plausible. You know.
Yeah, yeah. But then you see, you hear stories about the English sailors, sort of only in Elizabethan times.
You know.
And they came across some Eskimos in Greenland, shot 2 of them, captured the other one, brought him home to England because they thought it was some kind of animal, and that was just the prevailing attitude, really, of the people at the time. They didn't even think that other people were human beings if they didn't speak English, you know. An absolute shame. But I mean,
we're Christian.
There must have been a time previous to that where they were trading with people and treating each other correctly, you know. But you wonder when that happened.
Well, the French explorers at first were ordered not to interact with the natives. Like that'd be tainting them or something, and they adhered to it. It wasn't until after they saw what the Spanish did that they started doing it too, you know.
Yeah, yeah. Well, I mean, the conquistadors they were just kind of that money motivated. Absolutely insanely money motivated.
Yeah. Now, what country were the conquistadors in? I remember that song. You remember that song by Procol Harum?
Yeah.
Of course, I'm dating myself. I'm older than you guys. But, yeah.
No, Procol, I do remember it. It's a great song.
Oh, it is. Conquistador, your stallion stands. I love that song. I'm going to have to put it in my class of 76 list.
Yeah, brilliant.
Yeah. So
no, they went from Hispaniola, sort of the West Indies, and the first big landing that they hit was on the coast of Guatemala.
Mm-hmm.
And I've just I came across a fantastic show about Hernan Cortes.
Who's that?
and his life, and he wasn't the worst amongst them. There were some even more brutish ones than him, really. But they they didn't bother just execute the Wally. I mean, they just start burning them alive one after the next. You know, it wasn't They could have just cut them in half with the swords, but that wasn't easy enough for them. You know, they were far more brutal than that. Incredible, really.
Yeah, I heard they were pretty bad. I'd like to see them fight like Genghis Khan, you know, in a battle.
Well, it was,
Yeah.
you know,
That'd be cool.
You've got guys with metal armor on and 3-foot swords, guns.
Yeah.
And their opponents only have kind of linen armor, and they've got glass stuck in. I mean, they're fearsome warriors, but the weapons were, you know, just nothing in comparison, really. You know.
Yeah. New Earth. When I saw a couple of her shows recently, she was saying that the samurai class were Caucasian. They weren't Japanese. I wasn't aware of that.
Yeah, so you see, so this is all starting to come out now that they're more similar to the Finnish, the Japanese, going right down the old male lines, you know, finished to about 2,000 years ago.
Yeah.
So, you know, there's a lot of information that you do hear these rumours, and then 20 years later, you know, it becomes over. It's fact. Didn't you realise it's been fact for the last 10 years?
I know that happens in a lot of stuff. It really does. That's the way mainstream is. It ends up being a foregone conclusion.
It does, but I mean, it takes 30, 40, 50 years of discussing these facts. Like Japanese were related to some European tribes. And it takes, that is postulated, and it seems to disappear off the face of academia or anywhere else. And then the next time you hear of the subject, oh no, it's been well accepted for years and years.
You know, the Chinese...
But except no one's spoken about it.
Right. I never heard about it before. The Chinese used to build these gigantic ships and sail the ocean. Did you ever hear about that?
Well, yeah.
Yeah,
like where they can get,
man, they look like aircraft carriers.
Yeah, 20,000 ton ships.
Yeah.
Made out of wood.
Yeah. Intricate.
Now, I mean, they must have been able to get some serious damage on those ships.
My goodness.
Why have ships so big?
I don't know, man.
You'd think a few small ships would do the trick, but rather than have one big one, but.
Well, they had some crazy customs, you know, like when the king died, all of his concubines and servants get buried with him alive.
Oh, yeah. Everything.
Insane.
Yeah.
There's a guy who didn't want to go alone. He did, though. He still did. Bob Dylan has a classic line, "The deputy walks on hard nails, and the preacher rides a mount. But nothing really matters much. It's doom alone that counts."
Yeah, he can express it, Bob Dylan, can't he?
Yeah.
He really can express it.
Oh, yeah. He could. He didn't get to be the voice of the 60s for nothing. He wasn't exactly loaded with talent and singing and playing, but his style, it was just like something I had never heard before. It put a hook in me, you know? I think the first
it's charismatic.
I think the first Dylan song I heard, my brother was a Dylan fan, but he didn't become a fan until later when I learned all the ones, you know, Don't Look Twice, It's All Right, Highway 51, all those songs. But the first song I heard was "Everybody Must Get Stoned," and that song was a huge hit, right? That
Yeah,
song,
that
and
was really funny.
then right after that, like a Rolling Stone came out in that song. Whoa, man!
Yeah, brilliant. But Tambourine Man was my favourite. What sort of my earliest memory of Bob Dylan? Tambourine Man.
I just like that voice he's got. You think you've got it made, but it ain't like that. I wish sometime, you know, the way his style is, he just sings way off.
Oh, yeah.
Into left field and shit, you know. You mean it. You don't never hear anybody singing like that. Yeah. I remember the first time.
Well, that's it.
Yeah. The first time I saw him on TV, I was excited. Then I saw him playing. I'm like, oh, God, I was kind of embarrassed. He was terrible. But then another time, he was great. You just never knew what you were going to get with him. He got booed off the stage a few times. People wanted to see him do his acoustic thing.
An operatic singer.
And he went electric and just gave everybody the finger. Yeah. Well, how are we doing with the crowd? Do we actually got people listening to us ramble on? Or? Because I'm going to put on another, I'm going to put on one more audio, and then I think we're going to call it. Or we're going to finish this. Okay, so we got about, what? Well, an hour. We're about 40 minutes to go. And
all right, Greg. I'm going to dive back over there for a bit then and listen to the next bit of the show.
Yeah. I enjoyed it. Thanks a lot, Juicer. That was cool.
Cheers, Greg. See you in a bit, buddy.
Okay, man.
Into a great whirlpool-like structure that is currently thought to contain almost 1 trillion stars. When the stars near the sun are examined, they reveal the same variability among them, even though they are all considered to be siblings. The 20 stars closest to the sun in light years are, and there's the list: Proxima Centauri 4.2 light years, down to COD minus 3615,693, 11.7 light years from Earth. Such vivid imagination. Each star is different from the sun and from each other. Ross 248, for instance, is a red dwarf star, while Sirius A is a main sequence star 2 times the sun's mass. Although a few other stars in the list are red dwarfs, like Proxima Centauri, they are each unique in their spectral signatures. Various elements
Just heard my
are
boy
not
yawn.
distributed in the same way as the other spectrograms. Since the initial protogalactic cloud was undifferentiated overall, other stars near the sun should all be cut from the same cloth and contain similar chemical constituents. Surveys out of hundreds of light years, encompassing the nearest 6,000 stars, reveal that they are all different from one another, just like people. Some with more helium than others, some with more helium than their ages will allow, some with more iron than they should have, and other compositional oddities. Stephen Smith, man, he's a writer. Using the annual parallax produced by viewing the displacement as the Earth orbits the Sun of any nearby star against the background of very distant stars. The parallax measurement involves measuring the minute angle at the apex of an isosceles triangle, whose base is the diameter of the Earth's orbit about the Sun. Parallax angles are very small. The closest star, Alpha Centauri,
wonder what
is
Mickey
only
Mouse thought
displaced
that
to
up.
1.52 greater than arc seconds, or 1.52 arc seconds over the year. Man. This parallax, the largest, was not measured until 1839. R.H. Baker. Parallaxes are difficult to measure, and they cannot be determined for stars further from Earth than 652 light years. Such a small distance encompasses only 1,000th of the sphere of stars under close observation by astronomers. Thus, the majority of reported star distances and luminosities are derived by theory rather than measurement. Of the 21st magnitude stars, apparently brightest stars in the sky, only 5 are closer than 26 light years. The next 5 take us to 84 light years. The next 7 to 217 light years. And the next 5 to the measurement limit.
This sounds like Solaria Venerea, Chapter 1.
The parallax of one of these stars is only an estimate. 2 of the others are at the extreme limit. The last 3 are between 170
or maybe
and
the prologue.
192 light years distant. None of the most luminous supergiant stars are in this sample. Thus, all luminosities given for such stars are estimates. Even where parallax is measured, the measurement is rarely precise. Uncertainties of 25% and larger are common, leading to luminosities which are most likely erroneous in the order of at least 56%, about half a magnitude unit. Near the measuring limit, the possible deviations grow immensely, often exceeding considerably the number measured. The famous Hertzsprung-Russell diagram, the Rosetta Stone of modern astronomy, plots stellar luminosities against surface temperatures determined from the star's spectrum. Since the spectrum is often difficult to classify, placement on a star on a diagram is not always easy. R. H. Baker. To circumvent the difficulty, astronomers now rely upon color indices in place of spectrum classes. Such measurements are even more strongly theory-dependent than the former in terms of their applicability to stellar emissions. See Weiss, page 49. They are more quantitatively formulated, and therefore they lead to an unjustified sense of satisfaction with the computed result of the stellar condition. For our purpose, they offer no help. What we would say about the classification of stars is the following. In going from stars whose surface temperature appears to be high to those which appear cooler, there is a gradation of the lines present in the stellar spectra. The hotter stars show absorption produced by helium atoms. As we look at progressively cooler stars, the helium lines decline and abruptly hydrogen lines appear. They increase in intensity and slowly decline. As the hydrogen declines, the lines of the metals and metal ions increase in intensity. Through the solar-type stars, they dominate in stars slightly cooler than the Sun, only to be surpassed in the coolest stars by band spectra produced by various simple molecules, notably hydrides and oxides. And some of the coolest star compounds of carbon are prominent, although astronomers may
I loved that saying. Did you see that? It said, let the bulb of truth. That was beautiful. I got to remember that. It's coming up.
Intensity. Through the solar-type stars, they dominate in stars slightly cooler than the Sun,
it's in the video.
to be surpassed in the coolest stars by band spectra produced by
Merged the
various
universe.
simple
Imagine what the bulb
molecules,
of truth
notably
light your way.
hydrides
That's
and
really cool.
oxides.
I like that.
And some of the coolest star compounds of carbon
down.
are prominent. Although astronomers may continue to seek a more precise classification for stars,
It is so true.
to employ
It is so
the
true.
traditional spectral types.
When you're on the
for
right
present
side,
study.
you can't
Besides the Hertzsprung-Russell diagram, that is to classify the stars, astronomers have also divided the stars into populations according to their location within the galaxy. Some striking results were obtained. One of my favorite nebulas of all time, the famous Eye of God nebula, I believe it is called the Helix nebula, may actually be weeping tears of water. It's one of the most iconic celestial images in astronomy. The eye, like Helix nebula. Ironically, the incredibly harsh conditions within this dying sun-like star, are producing a molecule integral for the formation of water, by producing a molecule integral for the formation of water, a process that could be repeated across the cosmos. Planetary nebulas consist of an expanding glowing shell of ionized gas ejecting from old red giant stars late in their lives. The core becomes a hot white dwarf, pouring out ultraviolet radiation into its surroundings. This radiation can be so intense that it can actually destroy molecules that have been thrown out by the star, molecules bound up in the rings of material seen at the outer edge of planetary nebulas. Water-building molecule in Helix Nebula. Astronomers surmised that this harsh radiation restricted the formation of new molecules in those regions. But it now appears that this is not only incorrect, it may contribute to a process that generates a molecule responsible for the formation of water, a molecule known as OH+, a positively charged combination of a single oxygen and hydrogen atom. Oh, I said charged. A new study by Isabel Ailman of the University of Leiden, the Netherlands, shows that planetary nebulas, when exceeding temperatures of 100,000 degrees Celsius, produce OH+. We think that a critical clue is in the presence of the dense clumps of gas and dust, which are illuminated by UV and X-ray radiation emitted by the hot central star. Noted Ailman in an ESA statement, this high-energy radiation interacts with the clumps to trigger chemical reactions that leads to the formation of the molecules. There's a beautiful picture of it. I mean, I have seen so many awesome pictures of it, and I don't use that word lightly. I mean, when I say awesome, I mean truly awesome. That is just so compelling. A separate study by Mireia Exeluz of the Institut de Ciencia de los Materiales de Madrid, Spain, focused on the Helix Nebula, one of the nearest planetary nebulas to our solar system, a distance of 700 light-years. This nebula, which burns at 120,000 degrees Celsius, contains a rich variety of molecules. Looking at Herschel data, Excelencia's team found OH+ in locations where carbon monoxide molecules, previously ejected by the star, are most likely to be annihilated by the strong UV radiation. Once oxygen atoms are free from the carbon monoxide, they're able to make the oxygen-hydrogen molecules, a process that bolsters the hypothesis that UV radiation promotes their creation. These studies are the first to show how planetary nebulas may seed the cosmos with OH+, but the astronomers have yet to show that the conditions within would actually allow water formation to proceed. Read the studies: Herschel Planetary Nebula Survey, First Detection of OH+ in Planetary Nebula by I. Ailman, and Herschel's Spectral Mapping of the Helix Nebula, Photo Dissociation and the OH+ emission, are published in Astronomy and Physics. All right, let's head on over to the Thunderbolts again. And bingo, Helix Nebula. How about that? All right. March 2nd, 2015. Beautiful picture of Helix Nebula. A little different. I think that the reason why there are so many different pictures of it is because it's photographed in different light frequencies. An image of the Helix Nebula in the constellation Aquarius exposes more details of its electrical structure. The infrared image shows radio Birkeland currents, called strands, in the press release, crossing the concentric rings and converging on the central star. Will strands now replace the former stringy things? They don't know it's called Birkeland currents. They're either obtuse or ignorant, or corrupt, all three. Will strands now replace the former stringy things in the consensus lexicon? One can see especially well in high-resolution image that these currents consist of double filaments that spiral around each other and are evenly spaced around rings. Here you got PhDs, they see Birkeland currents, and they call them stringy things. Wouldn't that mean that it's open for someone on their side to say that they discovered it and name it after themselves? But they don't. Why is that? Well, I think it's because they know they're Brooklyn currents. From an electric universe point of view, the image is looking down the axis of the hourglass-shaped galactic current that powers the star. If viewed from the side, the nebula would have a structure like that of the Ant Nebula. The hourglass shape is caused by the Bennett pinch, from which the star originated and accumulated its matter. The rings will constitute secondary circuits, subject to their own pinch effects, which explains the concentration of glowing matter in them. The outer ring especially appears to consist of double filaments that twist around each other, exactly what is expected of an electric current in magnetized plasma. The bipolar extension of luminosity in the radial filaments, to upper right and lower left, may indicate a diffusion of ring plasma into the further reaches of the hourglass. The apparent inner ring actually may be located on the far side of the star, symmetric with the outer ring located on the near side. If viewed off-axis, the structure would be similar to that of SN 1987A, a beautiful supernova. Or perhaps the inner ring is located closer to the star in a more constricted part of the hourglass. The main ring is estimated to be about 2 light-years in diameter, and the outer reaches of the nebula can be traced to about 4 light-years. It's quite a ways, further than I thought. This provides an order of magnitude sense of the dimensions of the pinch and current powering the sun. Yeah, really. From which the recently discovered ring of energetic neutral atoms, ENAs, likely originates. The sun's plasma sheath, which the Voyager space probes are now entering, is located well inside the hourglass pinch. This sheath acts as the virtual cathode in the sun's discharge circuit and is coupled with the hourglass current in a manner yet to be determined. Torello-like experiments are needed to explore the mechanism and details of such plasma interactions. The concentrating and centralizing of funding and research since the establishment of NASA and its sister agencies have resulted in a flood of discoveries. However, it has also resulted in the establishment of a monopolistic consensus that has driven out research into alternative hypotheses. That is the sadness of it. The money talks. The poster boy for this disturbing consequence is Halton Hart, who was denied telescope time in 1983 to pursue evidence of intrinsic redshift. And I did a spotlight on him on my last space show, Space Show 3, in case you're interested. It's very interesting, to say the least. I mean, they are engaging in a religion at the people's chagrin. Experiments to refine the concepts of alternative hypothesis are unlikely to be done as long as the would-be investigators are exiles. They dig for spare minutes between the cushions of earning a living from other pursuits, and the few temporal coins they find are spent on conceptual outlines. Nothing is left for desperately needed experiments, and this says it all. The once proud queen of the sciences now offers herself for sale to the highest bidder on her street corner. The field of astronomy is no longer a seminar of science, but a battlefield between mercenaries and exiles. Mel Atchison. That was a great article, Mel. I enjoyed that. I remember when that picture was awesome. Now there's a bunch more that make that one pale. It just gets more and more like a human eye, it seems. And it's kind of ironic. I know from watching Suspicious Observers that stars can make water with hydrogen and oxygen at charge. But isn't it ironic that it's in the Aquarius constellation? You think that's a coincidence? And once again, I gotta give the better article to Thunderbolts by far. Anybody who loves cosmogony or cosmology, they're both the same, really. One just deals with origins. Anybody who loves that really needs to learn about Halton Arp and his ordeal. It will give you a different opinion of how things are done in science. If you don't know about Halton Arp's experiences with redshift, then you don't know the whole story and therefore cannot make a clear-headed, well-informed decision. Watch the Cosmology Quest. I have it in my Cosmology and Archaeology must-see playlist. It's not your fault. They bury it intentionally. You have to seek it out to ever get it. But I guarantee you, if you're interested in the truth, if you're watching all of these live cosmology shows, I know that you rarely ever learn anything new. You just keep getting rehashed information. They pollute the airways with that stuff. You don't learn a thing. It's just for eye candy. I know because I was once in the same position. Research the electric universe, and I'm not just saying this, I mean this is the truth. And the truth is what counts. You learn something new every time you read an article or watch a program. That's the difference. Now, I completely and fully understand about the petrodollar and how it's built the world, and I'm not by any means trying to be an advocate for free energy. But sometimes I just think that that's really what it's all about. And, you know, we can't get off the petrodollar. If we did, all the economies in the world would crash because everything was built on the automobile, and the rest of the world follows America.
Yeah, I don't
Whatever
think that
happens to
anymore.
America happens to the rest of the
This
world.
was a while ago. I don't think that anymore because the automobile's not even, it's gone. It's like everything else. We have no manufacturing anymore. It's gone. That's unforgivable. Manufacturing is what made America a great country. It's ironic, isn't it? Thanks, Bill. I have no idea what I was thinking here. I surely don't remember this. That's Sunset on Mars. Pretty good. I don't remember playing two songs at once. I must have been fried. They almost go together. 99 and 1/2 days. Wait a minute, something's wrong here. Reminded me of Red House. What's coming up next? I think we're at the end, man. I don't know. We got a little time left. Let's see. Got any more programs? I think so. Yeah. Yeah, we do. Okay. I don't think I made it this deep with the old edit machine. It has a little Clint Eastwood mixed with Viking vibe going into this thing. I love this song. I did this on Universal Sandbox. If it's the one I think it is, I made a little Saturn system, and then I made a Sun system, and then flew them into each other. Of course, you don't have the electrical force, and that's what runs it, but boy, if we did. You might be able to do some real physics on there if you had the electric force. No, I don't think this is the one. This is called ambient guitar. There's a whole genre for it now. Just playing like that. Good meditating music, if you can meditate to music. Oh yeah, now wait till you get a load of this keyboard. Sheesh.
Read some of it. I watched the Greg J. Show.
I was surfing around, I don't know, a couple weeks ago, and I found this Plasma Universe video from the University of Michigan, from their engineering or something. And lo and behold, in the comments, I saw it said Dr. Donald Scott, Electric Universe. And I thought that was pretty cute. So I asked them if I could use some of their video, and they said, sure, go ahead. So I'm going to play a little bit for you. See, it's getting around. They just haven't come all the way over yet. If it has to sneak in through the back door of the plasma physics academia, then so be it. Did you ever notice the truth never fully dies?
And current produces magnetic fields. And so I work on a topic called magnetic reconnection. And it has to do with how magnetic energy gets released. And perhaps more importantly, those a bunch of energetic particles, and those energetic particles are going to move out and threaten the life of the people who are traveling.
Environment, pretty much everything in the star is plasma, and the exterior of the star all the way through its local neighborhood is generally a plasma. So they're not hard to come by. In the universe, right, they're pretty much everywhere. We should ask the reverse question, why is it that we end up in not a plasma, right? Why are we living in a neutral fluid? And that's because we're in a kind of an unusual part of the universe, not the usual. So in the case of stellar physics, everything is a plasma. Everything is ionized everywhere, with some caveats to that, of course. The role of computation in the physical sciences is one that we really need to integrate much sooner and much more thoroughly. The Daedalus project, it's a software project that's now almost 8 years old. We kind of got together for exactly the purpose of trying to build software that was very flexible but very powerful for solving a certain class of equations called partial differential equations, which are sort of the tools we use most frequently to describe the motion of plasmas in this sort of fluid limit.
Hey fellas, have you heard about the Sapphire Project?
I believe any lasting contribution of the Sapphire Project is going to be in its raw data and hard empirical evidence. Correlating the data from Sapphire with the latest data from deep space is not as straightforward as it might sound. The Herschel and Planck millimeter telescopes have sent back new images of our galaxy's interstellar medium that have many in the astronomical community reeling. It is as if you're riding along and someone pulls a wheel off your bicycle. We are struggling to make sense of this data. It simply does not fit with our previous theories. The previous theories need to be abandoned or severely modified. I think we might need new models.
Part of a larger, a more energetic world. Look, for example, at this wonderful image from the Herschel telescope. We can see clearly that stars form on filaments, galactic filaments. I can tell you that none of the models of the old worldview predicted that. In fact, such a result would have been impossible. Situations similar to Chang Liu's paper. The old theories not only did not predict that stars would form this way, the old theories said it was impossible. Yet in the
did not match space scientists' theoretical predictions. In 2013, the lead author of a paper in the journal Science told Wired.com of the Voyager 1 data. The models that have been thought to predict what should happen are all incorrect. We essentially have absolutely no reliable roadmap of what to expect at this point. And today, scientists have reported that Voyager 2 has now also recently crossed the boundary into interstellar space. And again, the theoretical predictions based on standard solar physics do not match discovery. Don Gurnett, the corresponding author of a study published in the journal Nature Astronomy, said to phys.org, "In a historical sense, the old idea that the solar wind will just be gradually whittled away as you go further into interstellar space is simply not true. We show with Voyager 2, and previously with Voyager 1, that there's a distinct boundary out there. It's just astonishing how fluids, including plasmas, form boundaries." Of course, the predictions of the electric universe theory about the interstellar environment and behavior of the solar wind differ dramatically from convention. The electric universe has always proposed that a vast Birkeland current enters our solar system and, in fact, powers the sun. We asked retired professor of electrical engineering Dr. Donald Scott to offer his overview of the Voyager 2 findings to date.
Well, a few days ago, researchers at the University of Iowa announced that space probe Voyager 2 left the sun's heliosphere in late 2018 and entered what they think is the interstellar medium. Its sister probe, Voyager 1, did that earlier. I think it was back in 2012. And they announced that this latest transition was signaled definitely by and they emphasized a strong increase in the plasma density measured by the probe. In other words, the probe essentially went through what they refer to as a wall, a boundary there between the heliosphere and the interstellar medium. Well, these guys, astrophysics in general, is still in the mindset of fluid dynamics and gravity only. So you continuously hear words like winds and shocks and bow waves. And in fact, one typical astronomer commented on this latest release. He said, quote, "In a historic sense, the old idea that the solar wind will just be gradually whittled away as you go further into the interstellar space is simply not true." No kidding. We show with Voyager 2 and previously with Voyager 1 that there is a distinct boundary out there. It's just astonishing how fluids, including plasmas, form boundaries. Well, yes, in a sense, plasmas are fluid, but fluids are not plasmas. So, and do they form boundaries? Yeah, you betcha. Again, they seem to be surprised when they shouldn't be surprised. We in the electric universe realize that the discovery of an increase in the plasma density is completely consistent with the electric Bessel function model of a Birkeland current. So we're not surprised at all. The electric universe model of star formation, that is how the sun formed, is that it results from a Z-pinch in a Birkeland current filament inside our galaxy. And in our model, in the EU model,
Quite possibly in a Herbig-Haro object.
Ions, electrons, neutral atoms, molecules, etc., form in concentric cylinders. So it's quite probable that the outer cylindrical layer of the Birkeland current is a region of increased density. And so that's what the EU would have expected, and we don't look at it as a surprise or a discovery. It would be something we would be looking for. It's also true in the classical plasma lab experiment. Alfvén did them, Langmuir did them. There's often a double layer of charge just outside the cathode, just above the cathode. It's called the cathode drop. And in the case of the heliosphere in the electric universe model is the outer layer of the heliopause. It serves as a virtual cathode. And so thinking of it that way, we would expect to see an increased density of matter just at the cathode. And in our model, the heliopause is the cathode. So that again is what we would expect to see.
Well, we're coming to the end of the show. I think we'll call it. It's 5 hours, 4 minutes, 23 seconds. I don't want to quit, but I got another one of those things with court today. So I gotta do a little studying and getting ready. So I would like to thank everyone for coming. Let me see. I gotta say hello. Turn this down a little bit. This is a pretty song. I'm gonna put the camera on you. Let's see. Okay, so we gotta get out of this then. Just gotta go. Boom. There you are. Oh, look at that shit, man. See now when I look at you, Barrett Axblade is here, man. Gerald Wagster's hanging out for the duration for the Gold Thunderbolt. And he's the leading candidate. Randy Garcia, Barrett Axblade, Gerald Wagster. Alchemy 88. She's cruising. She's been here for a while too. Bye, Marma. Oh, you're saying bye because I'm going? I know, I hate going. You know, I really do. This is the worst time of the day. I have such a good time with everybody. And I appreciate you coming. I'll be back Saturday night. Okay? No, I'm in the lower. I'm in the LP. I'm down by Detroit. Yeah. Detroit. Comes from Cornwall. Cornwall. Not Cindy, right? I used to go to school with a girl named Cindy Cornwall. She was so beautiful. She didn't even know I existed, but man, I just look at her hair for 2 hours. Hi, Greg. Hey, Charlie. What's going on? You ever see one of them girls, you know, just so pretty, you're like scared of them? I was like in 8th grade or something, you know, 7th grade. But, yeah, I gotta go. I hate it, but I'm just gonna have to blink out. Let me see if I forget anybody. And Nat Foley was here. I'm sorry I missed you, Nat. Nat, yep. She was talking for quite a bit here. That's good. Charlie. And, reminds me of Ron. I see Andy, and I see... I was like 5. Nick, you still around? That's good, buddy. And I don't see Grouch. He must have crashed out on me. That's okay. He's a good guy. Just one moment, Greg. As always, thanks for... Oh, you're welcome. Yeah. I'm quirky. That's a good... I would say it's a good description. Yeah, that's fair. That's good. I don't mind being quirky. Text her now. Text who? Greg is the maximum master. Thank you, Alchemy. Still here. Well, yeah. Oh, there you are. Okay. See, I knew Grouch wouldn't be gone. I knew he was gonna. He's just kind of laying back. And Nick's here too. All right. Well, I'm not gonna leave now. I just have. Well, you know, because I can't edit if it's over 6 hours. And man,
it's going to increase.
The last one was
strength,
terrible. I did a lot of
plasma
mistakes.
tufts are going to go into.
All right,
the
we'll
arc
go for a
mode.
little longer.
You will see the photosphere. There they are. They don't like each other. It's like a bunch of kabuki warriors pushing each other away.
Now, where is that?
They're all positive, and they're all.
I guess I don't have it.
Looking for advantage and not finding it.
Wait a minute.
You might hear Monty's voice in the background if they have the audio on.
Oh, because I don't have this.
He's increased.
All right, I gotta change the page. I'll be right back.
The tufts have begun to go into. That's, I know the word. This
is cool because you see Callie. Watch, you'll see her. Just for a little bit, a couple seconds. I gotta change the camera. It's pretty. It's a couple of songs. Probably what it'd look like. That's probably what it would look like. It lives on a red dwarf planet. Those were huge when I was a kid. Monster cars. It was from a certain guy. He was famous for...
It's going to increase in strength.
Drawing
the
cars.
Plasma tufts are going to go into the arc mode.
Monsters and hot rods.
You will see the photosphere. There they are.
Come on, drop the pic.
They don't like each other.
Wait a minute.
It's like a bunch of kabuki warriors pushing each other away. They're all positive, and they're all looking for advantage and not finding it. You might hear Monty's voice in the background if they have the audio on. He's increased the current.
All right, you see Callie? You see it plain as day.
Go into, that's, I know the
Sun
word.
sticking out.
A high glow mode, or that's arc mode. You can see now, it's a better model that you can see the sunspots. Sunspots are where there are no tufts. There's something that he's got the excitation such that it looks like the chromosphere. That little black thing in the bottom, I guess Michael can tell me whether, is that the spectroscopic probe or it's a probe of some sort. There's the corona. The ring around the outside is the cathode. And of course, in the model, in the Sapphire model, you need a cathode. But in real space, of course, the cathode is a virtual cathode. But there's the corona. The reason that the corona there looks like it's only on one side is because the anode is closer to the cathode on that spot where you get the corona. If it were equally spaced, you'd see the corona all the way around. Sorry for the hokey ending there.
Boy, this one's loaded with music, huh? See, there's Lucy. It looks lonely out there. Amazing how a lot of these structures, these nebulas, look like they're alive. We watched this whole video. 3 hours, 51 minutes. It wasn't half bad. Now I got 2 of them. Oops. What to do, what to do. Alright, we're gonna show one more audio or video before I go. We're at 5 hours, 13 minutes, so we're still good. Wait a minute. No, man, I got something to do at 10:30. That's right. I gotta get prepared. I can't just go in last minute. We're gonna have to go soon. Thank you, everybody, for coming. It really means a lot to me. I appreciate coming to view the videos and supporting the channel. It means a lot, getting that truth out there to people. You gotta keep it up, keep on keeping on. It doesn't matter if people don't know what you're about the truth, they don't know, you don't have to convince them. As long as you know. That's all that matters. As long as you know. Honor and integrity are everything. If you lose that, you don't have anything. Goodbye. All right, we got a dude from the beginning. What was his name? I told him I had his back. I'm gonna give him a golden thunderbolt, and also, there was one more. I gotta come out there in a second. Gasper. Once again, no end screen. Your end screens are important because that's when people see your video, and there might not be one just stuck on the side, but they'll come up on the end screen. You can just click on the icon and go into the next video. I keep putting them up and they keep getting taken down. I don't know. I don't get it. Looks like two people. You see that? There's a guy there and there's a guy there. I know, man. I'm weird. I don't particularly want to see it. My eyes just go straight to it.